This whole part of our planet has disappeared. It used to be a tectonic plate, but something that big doesn't just vanish without a trace. And the clues that led to its discovery started in this mysterious gap between South China and the island called Borneo. For a long time, people thought the sea between these two places sat on a tectonic plate called Izanagi, which no longer exists. But wait, how does a tectonic plate just vanish like that? Alright, tectonic plates are like pieces of a puzzle all connected together. But instead of sitting on a table, they're floating on this semi-fluid layer. So they're always shifting and bumping into each other. And there's something else. Some pieces of this puzzle are heavier than others. And what happens is that eventually, a heavier piece slips under a lighter one. Something similar happens with tectonic plates, but it's less about weight and more about density. When the edge of one plate sinks below another and gets pushed down into the mantle, that process is called subduction. But it's not just the edge that can sink. Entire massive plates from the past have completely vanished into the Earth's mantle. That's exactly what happened to the Izanagi plate. About 130 million years ago, it started sliding under the Okhotsk plate, getting swallowed little by little. By around 55 million years ago, it was completely subducted and replaced by the Pacific plate. And for years, specialists thought that the ocean between China and Borneo was sitting on that plate before it disappeared. Cool, but the experts got it wrong. Turns out the ocean between these lands wasn't sitting on the Izanagi plate after all. Instead, it fits into this weird, unexplained gap, as if a piece of the puzzle was missing. Recently, researchers at Utrecht University finally discovered that this gap was actually a ghost tectonic plate that no one knew about, the Pontus plate. It got its name because back when it existed, it sat beneath the ancient Pontus Ocean. But if it vanished so long ago, how did experts find it, right? Luckily, tectonic plates sometimes leave traces before they completely disappear. But instead of investigating footprints or fingerprints, it's more about looking for rocks. Yeah, stones from a lost plate can get incorporated into mountain ranges and show us where those ancient earth layers were. That's because rocks have a special power to record Earth's magnetic field. You know, that invisible shield that protects our planet from space threats, like solar wind and cosmic rays? So, as rocks cool and solidify, the magnetic materials in them, like magnetite or hematite, line up with Earth's magnetic field at the time and get locked in. They can freeze a record of the magnetic's field direction and strength. And since it changes depending on latitude, basically whether it's further north or south on the planet, it allows the rocks to kind of take a snapshot of their ancient position relative to the equator. Knowing this, researchers traveled to Borneo to collect and study the rocks over there. And they discovered something odd. These stones were originally from a much farther north region. Their ancient coordinates didn't match the latitude they expected for Izanagi. In fact, they didn't match any of the tectonic plates we knew about up until then. So they quickly realized two things. One, they had just discovered an eerie gap. Two, there must be a hidden ghost tectonic plate that used to be in that spot. To unravel the mystery, scientists used computer models to study the region's geology over the last 160 million years. Thanks to this technology, they were able to piece together the entire Pontus plate in all its glory. The next step was to figure out the key features of this part of our planet that had been submerged, like its age. You see, the rock samples collected in Borneo date back 135 million years, back when dinosaurs ruled the Earth. With this information, scientists realized that the Pontus plate was formed at least 160 million years ago, but it's probably even older than that. Although it is hard to pin down exactly when it was formed, one thing we can say for sure: it was huge. the Pontus Plate was about 1/4 the size of the Pacific Ocean. Unfortunately, by around 20 million years ago, it said bye-bye to the planet, sinking and being completely pushed under the Australian Plate to the south and China to the north. At this point, you might be wondering if a couple of rocks and a computer reconstruction are enough to prove that the Pontus Plate really existed. Well, yeah, they are. But other clues have also been found in Palawan, an island in the western Philippines and in the South China Sea. The truth is that the scientific community has suspected the existence of Pontus for over 10 years. At that time, researchers were really focused on the area around the Philippines. This region is like a playground for geologists, since it sits at the crossroads of several tectonic plate systems. So, scientists decided to reconstruct the movements of the Earth's crust between Japan and New Zealand. And because of that, the study suggested there had to be a subduction zone running through there, separating the known Pacific plates in the east from the hypothetical Pontus Plate in the west. These previous predictions were possible because tectonic plates are really bad at playing hide-and-seek. Like we said before they get submerged, they leave clues behind. And it's not just rocks. They can also change the Earth's mantle, which leads to the formation of volcanoes, earthquakes, and deep ocean trenches, for example. But the subduction process can also mess with the composition and temperature of the mantle, making some areas hotter or cooler. These are considered anomalies. It is possible to detect these anomalies using seismographs, which are instruments that pick up earthquake signals and record the ground's motion. When earthquakes happen, they send out ripples or waves through the Earth. These waves travel through the Earth's layers, but if they hit something unusual like an ancient piece of a tectonic plate hidden in the mantle, the waves get disrupted. It's like hitting a bump on a smooth road. It messes with the ride. Using regular seismometers to look for anomalies is fine, and it can totally help us find clues about the Earth's past. But if scientists want to use this method to get pictures of what's really going on beneath the surface, it gets a lot trickier. Not only do the images come out in low resolution, but the process also becomes insanely expensive. So recently, experts just uncovered a cutting-edge technique that could completely change the way we look at the Earth's depths. Kind of like an ultrasound, scientists can now actually see what's happening miles beneath our feet. More specifically, in a region between the Earth's brittle crust and the mantle underneath, known as the MOHO. This new method is called Distributed Acoustic Sensing, or DAS. It uses fiber optic cables, the same ones that give us high-speed internet, as earthquake sensors. Here's how it works. Laser beams are sent through the cables, and when the ground moves, whether from an earthquake, traffic, or other vibrations, the shaking changes how the laser light bounces around inside the cables. The cool part is that we can now measure these changes all along the length of the cable, so the cable ends up acting like hundreds of tiny earthquake detectors spread out over a huge area. This new tech can tell us things like whether major faults go all the way into the mantle, how ancient and modern processes have shaped the continents, and how strong the deep crust is in certain areas. In other words, DAS could be a game-changing instrument to help us uncover new clues about hidden and ancient tectonic plates.
In February 2025, scientists discovered something shocking about our planet's insides. We've long thought that Earth's inner core is a solid and stable sphere, but the truth may be quite different and a bit alarming. The recent study suggests that the surface of the core might be undergoing structural transformations right at this moment. Researchers from the University of Southern California have analyzed decades of seismic data and discovered that the surface of the inner core appears to deform under the influence of the outer core. We've observed such changes for the first time, but they're likely to explain some peculiarities in the rotation of the inner core. They could even be influencing the length of days on Earth. Now, the inner core of our planet, located about 3,100 miles below the surface, is traditionally described as a solid ball of iron and nickel. However, new data shows that its outer layer may be more malleable than expected. This discovery is based on the analysis of seismic waves from repeated earthquakes near the South Sandwich Islands. The researchers used enhanced resolution techniques to study these seismic signals. They observed anomalies in the waves and made an unexpected conclusion. There must be deformations on the surface of the inner core, and they could be caused by turbulent interactions with the molten outer core. Now, this outer core, composed of liquid iron and nickel, has a highly important role. It helps generate Earth's magnetic field. Before, we really didn't understand its impact on the inner core. But now, the new study shows that the turbulent movements of the outer core could disrupt the surface of the inner core, and that could cause changes in its shape. These disturbances might also explain the gradual slowdown in the rotation of the inner core. Scientists have been observing it since 2010. On the surface, we really don't notice these changes, but they could influence Earth's overall rotation and length of days. The study can help us understand better what's happening deep inside our planet, how the inner and outer core interact, and how that affects Earth's magnetic field and movement. Obviously, direct observation of Earth's core is impossible. That's why scientists use indirect methods, like analysis of seismic waves. It also allows us to deduce the structure and composition of the core. As these waves pass through different layers, they get deflected or stopped, and this can provide us with clues about the nature of the materials they encounter. There are also laboratory experiments. Researchers reproduce the extreme pressures and temperatures of the core and study the behavior of iron-nickel alloys. They use sophisticated instruments, such as diamond anvil cells, and they allow exploration of these extreme conditions. Then there are studies of meteorites. The thing is, some of them come from asteroids with a metallic core like Earth's. Their chemical composition sometimes provides clues about the elements present in Earth's depths. Scientists can also create numerical models. By combining seismic, experimental, and geochemical data, they simulate the internal dynamics of our core. But what would happen if Earth's core suddenly stopped spinning altogether? Well, it's unclear, but we can make assumptions. If it was just the solid inner core that stopped, the answer would be, not much. Even if it didn't just slow down its movements, which is happening right now, but stopped altogether, the main impact would be on the speed of Earth's rotation. Our days would get longer. Over time, it could weaken the planet's magnetic field, which would be bad news, but not as catastrophic as what would happen if the outer core stopped spinning. That's when things would get seriously bad. Without the rotation of the outer core, Earth would lose its magnetic field, and the loss of this protective shield would set off a catastrophic chain reaction. First off, tectonic plates would start colliding in chaotic ways. Imagine being on a bus when the driver suddenly slams on the brakes and you go flying into other passengers or on the floor. The planet would experience something similar, but with tectonic plates. Ew. These violent collisions would cause massive earthquakes along plate boundaries worldwide, shaking buildings, bridges, and roads. Water systems, electricity, and phone lines would be destroyed in the chaos. But this would only be the start. Without the magnetic field, cosmic radiation would start hitting Earth's surface. These high-energy particles from the Sun would interact with the oxygen and nitrogen in our atmosphere, damaging the ozone layer. This would allow even more radiation to reach Earth's surface, causing even more damage. Electronics would fail, power grids would collapse, and communication systems would go dark. But the effects wouldn't be limited to just humans. All forms of life would be at risk. Many animals, like migratory birds and turtles, rely on Earth's magnetic field for navigation. With it gone, they would be completely lost. Birds would lose their sense of direction, and turtles wouldn't be able to find the beaches where they need to lay their eggs. Luckily, we don't need to worry about this apocalyptic scenario anytime soon. The outer core of Earth is very unlikely to stop spinning in our lifetime or ever. So for now, we're safe. But to truly understand Earth, you need to go 4,000 miles beneath our feet. Earth has 4 main layers, from the very center to the surface: the inner core, outer core, mantle, and crust. Now, except for the crust, no one has ever explored these deeper layers in person. The deepest humans have drilled is just over 7.5 miles, and that took 20 years to achieve. At the very center of Earth is the inner core, a solid metal ball about 758 miles in radius, which is about 3/4 the size of the Moon. It sits about 4,000 to 3,200 miles below the surface. Made mostly of iron and nickel, the inner core is incredibly dense. It spins a bit more slowly than the rest of Earth and is intensely hot, reaching temperatures of 9,800 degrees Fahrenheit. It's like the surface of the Sun. The pressure there is staggering, over 3 million times greater than the pressure we feel on the surface. Some research even suggests that there might be an even smaller, denser core inside the inner core, thought to be made mostly of iron. The outer core is also made of iron and nickel, but in liquid form. It sits about 3,200 to 1,800 miles beneath the surface. The heat here comes mostly from the radioactive decay of elements, like uranium and thorium, causing the liquid to churn in massive, turbulent currents. This motion creates electrical currents, which generate Earth's magnetic field. Interestingly, Earth's magnetic field reverses about every 200 to 300,000 years, and scientists are still trying to figure out exactly why it happens. The mantle is Earth's thickest layer, stretching almost 1,800 miles deep. It starts just around 19 miles beneath the surface. Made of iron, magnesium, and silicon, it's dense, hot, and semi-solid. To imagine it better, think about caramel candy. Like the outer core, the mantle also circulates, but it moves much more slowly. Closer to the upper edge of the mantle, between 62 to 124 miles underground, the heat is so intense that it melts rock. This creates a partially melted layer of rock called the asthenosphere. Geologists think that this soft, hot, and slippery layer is what allows Earth's tectonic plates to move and slide. Some of the diamonds we find on Earth come from the mantle. Most of these diamonds form at depths above 124 miles. But rarer, super-deep diamonds may form as deep as 435 miles. These diamonds are brought to the surface by a certain kind of volcanic rock called kimberlite. The outermost part of the mantle is cooler and more rigid, behaving more like the crust above it. Together, this uppermost part of the mantle and the crust are called the lithosphere. As for the crust itself, it's the outermost layer of Earth. It's about 25 miles deep and makes up only 1% of the planet's mass. And yet, it holds all known life in the universe. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60 but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts. So, you might have heard that Yellowstone National Park is sitting on top of a giant supervolcano. That's a reason why the area can boast powerful geysers and hot springs. But it also means that underneath Yellowstone, there is an enormous magma chamber. In 2015, researchers from the University of Utah found out that this chamber was much bigger than everyone had previously thought. They even found one more reservoir with magma under the top one. Apparently, the more spacious the chambers are, the more magma they contain. Together, the two reservoirs store a glob of magma that could easily fill the Grand Canyon not once, but 11 times. But you know the most worrying thing about the magma chambers? They tend to push against the ground above them. As a result, the land in Yellowstone rises about 1 to 2 inches a year. On top of that, Yellowstone has the status of an active volcano, and its volcanic explosivity index, yes, there is one, is 8 out of 8. Such a high number means that if this volcano erupted, it would be an apocalyptic event. To put it into perspective, the eruption of Pinatubo in the Philippines in 1991, which is considered the most powerful in living memory, was given a mere 6 on the volcanic explosivity index. Ha, loser. Now, let's figure out if there's anything to worry about. In March 2023, the University of Utah seismograph stations recorded 354 earthquakes in the entire region of Yellowstone National Park. Sounds like a lot. But keep in mind that the most impressive event of the month was a mini earthquake of magnitude 3.7. It was part of a swarm of 106 earthquakes that began on March 29th and continued until the end of the month. Yep, earthquakes apparently also come in swarms, so be aware. Experts say that Yellowstone's seismic activity is, well, kind of more active than usual, but it's really nothing serious. A geophysicist working at Yellowstone Volcano Observatory called Michael Poland claims that the volcano won't erupt anytime soon. For this to happen, there must be enough magma ready to erupt beneath the surface. Whew. There should also be enough pressure to cause this magma to rise. But neither of these conditions exist today. According to the expert, Yellowstone is stable now. At the same time, Poland and his team are keeping track of all kinds of underground activity, looking for warning signs of possible eruptions. Some of them can be the frequency of earthquakes and ground deformation. Thousands of mini earthquakes, coupled with extreme changes in the surface of the ground in that area, can be alarming. The team also monitors the temperature of the park's thermal features. That's another noteworthy sign of a potential disaster: park-wide changes in geyser activity, as well as gas and thermal emissions. So, despite the media claims that Yellowstone is due to erupt soon because the last eruption happened 70,000 years ago, that's not how volcanoes work. Experts say that it's one of the most popular misconceptions about volcanoes. They don't follow timelines. If a supereruption did happen, though, the most worrying thing for us would not be the lava flows, and not an earthquake that would most likely accompany the natural disaster. No, the worst consequence of such a supereruption would be ash and ashfall. Let's have a look at what it was like when the Yellowstone volcano erupted many years ago. There have been at least 3 supereruptions in the history of the volcano. The most powerful of them was 2,500 times more devastating than the terrifying eruption of Mount St. Helens in Washington state in 1980. As for the most recent supereruption, it was dubbed the Lava Creek eruption. It formed the Yellowstone caldera after spewing out an insane amount of dust, volcanic ash, and rock into the air. Recently, scientists have also learned about 2 other previously unknown supereruptions that happened around 9 and 8.7 million years ago. The younger of the 2 is now considered to be the largest recorded event of the whole Snake River Yellowstone volcanic province. Anyway, let's have a look at what was going on all those millions of years ago. Because I wasn't around then, so we're all assuming this stuff based on evidence. The first signs of the disaster appeared long before the catastrophe broke out. For thousands of years, the heat had been welling up from within the planet's insides. It had been melting rock beneath the planet's crust and leaving behind huge chambers. They were filled with a pressurized mixture of semi-solid rock, magma, water vapor, and different gases, including carbon dioxide. All this scorching underground soup was expanding since more and more magma arrived with time. The land over the volcanic system was rising upward almost unnoticeably. A year before the supereruption, Yellowstone gave a warning, a burp maybe, but that long ago there was no one who could interpret these signals. Plus, those alarming processes were mostly going on underground. For example, decompression releases gas bubbles. While bursting, such bubbles can often power particular kinds of eruptions. Months before the eruption, small-scale earthquakes became more frequent and more intense. The ground in many spots all over the supervolcano got hotter than it used to be. Surface lakes and groundwater also became warmer. If people had been around at that time, they would have noticed unusual steam fogging in that area. Not long before the eruption started, the growing pressure pushed the ground over the magma chamber up. This created a dome-shaped uplift. Narrow cracks started to open along the edges of this dome. Imagine opening a bottle of soda after you've shaken it. Something like that was happening near the volcano. Think Mentos and Diet Coke. The pressure was released through the fractures when gases were bursting out from under the surface. So right before the disaster, the ground around the Yellowstone volcano lifted. Geothermal pools and geysers heated up to boiling temperatures and got more acidic than usual. The magma started to rise toward the surface. At one point, the rock roof of the magma chamber couldn't resist anymore and the eruption kicked off. Small but constant tremors began to move the ground days before the catastrophe. But the real shaking didn't start until several minutes before the eruption. With a deafening roar, a massive column of lava and ash hurled up into the air. Within several minutes, a pyroclastic flow rushed across the area at a hurricane-force speed. Such a flow is a liquid mixture of half-solid lava pieces, volcanic ash, and hot expanding gases. It looked like an extremely hot toxic snow avalanche. With a temperature of about 1300 degrees, it was burning everything in its path. The volcano kept pumping ash for days on end. For all living creatures, ash fallout was one of the most dangerous consequences of the eruption. Volcanic ash turns into glassy cement within seconds of being inhaled. Most animals didn't have a chance to survive. Even thick trees started to collapse under the weight of this dense substance. It only took a couple of days until a thick layer of ash covered huge territories. After the ash got into the stratosphere, the temperatures all over the world started to drop. The eruption was rich in sulfur, which is an effective sun blocker. That's why it soon got so cold that there was no summer in the whole world for the next several years. Animals couldn't find food and clean water. This natural disaster, called the Gray's Landing supereruption, was colossal. That's how researchers described it in their recent studies. It affected a huge territory. The streams of lava enameled an area as large as New Jersey in scorching hot volcanic glass. It instantly sterilized the land surface, wiping out all the plant life that had been thriving there before. Now, if such an eruption were to happen these days, it would cover Colorado, Utah, and Wyoming with almost 3 feet of toxic volcanic ash. Many regions would be plunged into darkness. Even the coast, where most Americans live, would experience problems with the spread of the ash cloud. It would destroy crops and contaminate pastures, ruin power lines and electrical transformers. Well, so I'm sure you'll agree with me, it's a good thing that such a disaster isn't expected to occur anytime soon. Hey, we got enough other stuff on our plate.
It's official. Official. A day will no longer last 24 hours. Earth's now spinning faster, literally, and our days are going to get shorter. At the moment, it's believed that the shortest day happened on July 10th, 2025. It was shorter not by much, just a fraction of a second, 1.36 milliseconds according to most sources, but still. And all because of the moon's position messing with Earth's rotation, just enough to speed things up. If it turns out to be not a one-time thing and Earth keeps spinning faster, it could be the start of a big mess. All our time stuff like GPS, the internet, atomic clocks, even how countries keep time, depends on the day being 24 hours. But if the planet speeds up, those systems could totally freak out. Clocks would get all out of whack, and anything that needs perfect timing could go sideways. We're talking about more than just a few lost seconds. This could shake up everything. Flights, money transfers, basically how we live day to day. We'll have to rethink how we measure time. Are you ready for that kind of chaos? Now, normally a day is 24 hours, or 86,400 seconds, because that's how long it takes for the planet to do a full spin. But Earth's rotation isn't always stable. A bunch of things influence it, like where the sun and the moon are or how the planet's mass is balanced. Earth is like a giant spinning top, and anything can throw it off rhythm. But our planet has been slowing down for a long, really long time. Because according to scientists, about 1 to 2 billion years ago, a day only lasted 19 hours. Not because the planet was lazy or anything. Nope, it was the moon's fault. It was way closer to us back then. Its gravity had a stronger pull, and that made Earth spin faster. And that faster spin meant shorter days. The thing is, the moon is slowly drifting away from Earth, and as it does, Earth's rotation slows down, and our days get longer over time. But during that billion-year window, something weird happened. The moon kinda just hovered at a certain distance. It wasn't moving out, it wasn't pulling harder. It was like it paused. And that pause locked us into 19-hour days for what scientists are now calling a boring billion. It was a time when pretty much everything on Earth slowed down. Tectonic activity was stable, the climate wasn't doing anything weird, and even life kind of plateaued. Now, let's get into the sciencey part. The moon's gravity controls our ocean tides. That's what slows down Earth's spin. But the sun pulls on Earth too, just in a different way. When sunlight hits Earth's surface and heats it up, that creates what's called solar atmospheric tides, and those can actually speed up Earth's rotation. Right now, the moon's gravitational tides are about twice as strong as the sun's atmospheric tides, which means the moon is in charge when it comes to Earth's spin. But back in the boring billion, the sun and moon were basically in a tug-of-war with equal strength. This phenomenon is called tidal resonance. It's like Earth hit a cosmic pause button. If the moon hadn't backed off, we might still be living in a 19-hour-day world right now. These days, the moon is still drifting away from us, and because of that, our days are slowly getting longer. Until lately, things have gotten weird. In the last few years, scientists noticed that Earth hasn't been sticking to schedule. In fact, it's been spinning faster, and I mean record-breaking fast. Back in 2020, Earth started picking up the pace more than it had since scientists started clocking it in the 70s. Then came July 5th, 2024, the shortest day ever recorded. We lost 1.66 milliseconds. Not a big deal if you're just watching videos on YouTube, but on a planetary scale, it's kinda huge. Now, we get back to July 10th, 2025. On that date, the moon was sitting way up near the poles, very far from Earth's equator. And that changed the game. When the moon is hanging out closer to the poles, it messes with Earth's rotation and makes our days a little bit shorter. That kind of change isn't unusual. Earth's spin has always had some ups and downs. But today, the moon isn't the only factor. According to NASA, human activity is changing how Earth spins too. Between 2000 and 2018, moving ice and pumping groundwater around the planet shifted enough mass that it added 1.33 milliseconds to our days per century. Natural disasters can mess things up too. Remember the massive earthquake that hit Japan in 2011? It actually shortened Earth's day by 1.8 microseconds. Just one quake, one microjolt to the planet's schedule, but the consequences were catastrophic. On March 11, 2011, at exactly 2:46 p.m. local time, a huge earthquake hit off Japan's east coast. We're talking magnitude 9, one of the biggest quakes ever recorded. The epicenter was about 80 miles from Sendai and over 230 miles from Tokyo. Japan's main island shifted 8 feet. Yes, the ground moved and whole cities literally slid, but it didn't just shake buildings and trigger a tsunami. The quake was so strong it redistributed Earth's mass, like shifting weights around on a spinning top. When you do that, the top spins differently. Same deal with Earth. The movement of tectonic plates was enough to tweak the whole planet's rotation. The thing is, the earthquake moved land and shifted Earth's figure axis. That's the axis our planet's mass balances around, by 6.5 inches. That's separate from the north-south spin axis, which we rotate on daily at about 1,000 miles per hour. But still, that shift was enough to make Earth wobble differently as it was spinning. It didn't tilt the entire axis in space. Only stuff like the sun or moon's gravity can do that. But it was still a major shakeup, no pun intended. And it wasn't the first time this had happened. The 2004 Sumatra quake, a staggering magnitude 9.1, sped up Earth's spin and cut 6.8 microseconds off the day. Chile's 2010 quake took off another 1.26 microseconds. Every time one of these mega quakes hit, it's like Earth gets a tiny jolt, spinning just a hair faster. And it might not be over. For example, that March 11 quake unleashed more than 80 aftershocks that were magnitude 6.0 or higher. Long after, some of those aftershocks were still tweaking the day length. It was very subtle, changes in millionths of a second, but real. But the thing is, even the seasons can mess with how fast Earth spins. A geophysicist from the University of Liverpool has explained it like this. There's way more land in the northern hemisphere than in the south. So, during northern summer, trees grow leaves, and that leaf mass moves upward, farther from Earth's center. And it sounds pretty harmless, right? But no, that tiny shift actually slows down our planet's spin, just a bit. Think about a figure skater, arms in. They spin faster. Arms out, they slow down. Same with Earth. When its mass shifts away from the core, it rotates more slowly. So yeah, in the summer, Earth literally chills a bit, spin-wise. Now you don't panic about your day suddenly feeling longer yet. Your clock is still gonna say 24 hours. That's just how our timekeeping works. As for these differences, they're milliseconds. You'd never feel it. But the problem is that over time, it all adds up. If the planet ever spun slow enough that we were off by more than 0.9 seconds, then we'd have to do something. That's when the International Earth Rotation and Reference System Service steps in. These are the people who keep tabs on Earth's spin, and if things drift too far out of sync with our clocks, they throw in a leap second to fix it. Yep, they literally add a second to the clock every now and then to keep Earth time on track. It's like the universe's version of a software update. In any case, with the moon slowly drifting away and Earth calming down, the fact that our planet is suddenly picking up speed, even just a little, makes experts and ordinary people raise their eyebrows. It's a reminder that even something as basic as a day isn't set in stone. The planet's moving quicker. Time is literally slipping. Something's shifting. There's an old volcano in Bolivia called Uturuncu. It hasn't erupted in about 250,000 years, so you may think that's the end of its story. But recently, it has started to act a little strangely. At the moment, it resembles a zombie that's waking up from a long nap. Uh-oh, is that kind of apocalypse nearing? Uturuncu is a huge mountain in the Andes that's almost 20,000 feet tall. It's called a stratovolcano, which means it's big, steep, and cone-shaped. These kinds of volcanoes are made from layers of lava, ash, and rocks. They can have terrifying, powerful, explosive eruptions because their lava is thick and traps gas inside. Think of it like a shaken-up soda that's ready to burst. Famous ones like Mount Vesuvius are just like Uturuncu. And do you remember about the tragic fate of Pompeii, completely destroyed during the eruption of Mount Vesuvius? Does something similar await Bolivia? Even though Uturuncu has been quiet for a long time, scientists have noticed that it's been letting out gas, rumbling with small earthquakes, and even making the ground around it bulge, kind of like it's stretching. So, people started wondering if it was getting ready to erupt again. Scientists decided to take a closer look at this situation and found out that liquid and gas moving around under the volcano is causing all this activity. It doesn't mean the volcano is definitely going to erupt, but it helps explain why it still seems alive. Let's dive into details. Since the 1990s, scientists have been using satellites and GPS to keep an eye on the ground around the Uturuncu volcano. At one point, they noticed something weird. The ground was rising in the middle and sinking around the edges, kind of like a sombrero hat. The middle part has been slowly going up for at least 50 years, by about 0.4 inches a year. It doesn't sound like a lot, but hold on. This strange shape, along with lots of tiny earthquakes and gas like carbon dioxide coming out of the volcano, made scientists think that there might be a giant blob of magma growing under the mountain. If that were true, it could mean only one scary thing. The volcano could be getting ready to erupt. Uturuncu sits on top of a huge underground pool of magma called the Altiplano Puna magma body. This pool is really big and really deep, stretching under parts of Bolivia, Chile, and Argentina. Scientists thought that magma from the APMB might be rising and collecting near the surface, which could lead to an eruption. But now, after studying more than 1,700 earthquakes and checking the rocks around the volcano, scientists have a new idea. Apparently, it's not magma rising up. Instead, hot fluids and gases are traveling up from the APMB through a narrow path shaped like a chimney. These gases, like steam and CO2, can get trapped under the top of the volcano, while salty water, brine, spreads out sideways into tiny cracks in the rocks. This moving gas and water can make the ground rise and fall and cause small quakes, without any magma getting close to the surface. So the good news is, Utarunku probably isn't about to erupt. If it did happen, it would cause serious damage to nearby communities and even pose a threat to human lives. Lava flows could reach towns tens of miles away from the volcano, and volcanic ash could even spread across Bolivia, Argentina, and Chile. Luckily, even though the volcano is still alive and rumbling, it's not as dangerous as scientists once thought. This discovery might help scientists figure out if other volcanoes around the world are getting ready to erupt. Now, let's visit Alaska, where according to researchers, Mount Spur might erupt soon. It's letting out strange amounts of volcanic gases from the top and side vent, the very vent that last erupted in 1992. If it erupts again, it could cause problems for airplanes flying nearby and might send ash falling from the sky. The good news is that nobody lives close to it, so people are safe for now. But even though Mount Spur isn't super dangerous, there are other volcanoes around the world that could be really destructive. One of those is Campi Flegrei, a giant volcano system near the city of Naples. Instead of one big mountain, it has 24 craters spread across the area. It last erupted in 1538, but its biggest eruption happened about 40,000 years ago. That explosion covered the whole Mediterranean region in ash and made temperatures drop by up to 16.2 degrees Fahrenheit in Eastern Europe, which led to a very cold volcanic winter. If Campi Flegrei erupted again today, it could be very dangerous. It might cover Naples and nearby places in ash, causing earthquakes and landslides, and create air pollution and acid rain. Scientists are keeping an eye on it, especially after a 4.4 magnitude earthquake shook the area in March 2025. But the good news is, there's no sign that magma is rising to the surface right now, which means an eruption isn't expected soon. Still, since Italy has a lot of volcanic activity, experts continue to watch it carefully. Mount Vesuvius is also in Italy and is one of the most famous volcanoes in the world. It's known for its huge eruption in 79 CE that buried the Roman cities of Pompeii and Herculaneum. The last time the volcano erupted was in 1944. Today, Vesuvius is even more dangerous because over 3 million people live near it. Around 700,000 people are living illegally right on its slopes, which puts them even more at risk. If the volcano erupts again, it could send rocks and ash flying through the air at nearly 100 miles per hour and cause major destruction, possibly even wiping out Naples. And still, scientists believe a big eruption from Vesuvius probably won't happen for a few hundred more years. But since it's still an active volcano, researchers continue to monitor it. Cumbre Vieja is a volcano on the island of La Palma, which is part of the Canary Islands. It last erupted in 2021. During that eruption, lava poured out of the volcano and flowed all the way to the sea. It destroyed over 3,000 homes, but luckily, thousands of people were safely evacuated, so it wasn't as bad as it could have been. In the past, scientists were worried that a huge eruption could cause the entire western side of the volcano to break off and crash into the ocean. This could create a mega tsunami, sending massive waves hundreds of feet high across the Atlantic Ocean. but more recent studies have shown that this is very unlikely to happen. Mount St. Helens is a volcano in Washington State in the United States. It had a massive eruption in May 1980 that ended the lives of 57 people. That eruption also caused the biggest landslide ever recorded. Hot, pressurized magma exploded from the volcano, shooting ash 15 miles into the sky. Ash covered a huge area, and around 230 square miles of land was destroyed. Mount St. Helens is still active and is expected to erupt again someday, possibly even in our lifetimes. But experts say it's not likely to have another huge sideways blast like the one in 1980, thanks to a deep crater that is now formed at the top. It will change the way the volcano might erupt. Popocatépetl is a big, active volcano in Mexico. It's been slowly erupting on and off since the early 2000s. It's really close to a lot of people, just 40 miles from the Mexico City metropolitan area, which has about 22 million people, and 30 miles from Puebla, which is home to about 6 million inhabitants. If Popocatépetl had a huge eruption, it could cover Mexico City in thick ash as much as 8 inches deep. That ash could block drains, mess up the water, and even stop the electricity from working. Even worse, fast-moving lava and super hot flows, called pyroclastic flows, could rush down the mountain and destroy towns nearby. The volcano was quiet for 50 years, but now it rumbles and shakes pretty often. There have been over a dozen small eruptions, including some as recent as February 2024. Some nearby places got covered in ash, but scientists say this isn't too surprising, and they're keeping a close eye on it.
Get ready, because one of the Pacific Ocean's most active volcanoes might blow any minute now. Scientists monitoring axial seamount, a gigantic underwater lava factory just off the coast of Oregon, say it could erupt literally any time between today and early 2026 at the latest. Yes, it's underwater, but don't get tricked by the ocean's cover. This beast is almost 3 times taller than the Empire State Building. This volcano is inflating like a souffle at a Michelin-starred restaurant, and scientists are so excited they will live stream it. Seriously! So here's the thing. This volcano will explode at any moment now because, well, it's inflating fast. Over the past few months, researchers have noticed that the seafloor is literally rising. It's like Axial is doing its best impression of a waterbed filled with molten rock. Scientists call this inflation, which sounds like something you'd complain about after Thanksgiving dinner. But in volcano terms, it means magma is piling up underground, causing the seafloor to bulge like a souffle that's this close to collapsing. Now, an underwater volcanic eruption might not sound so exotic. After all, most volcanic activity on Earth happens under the sea. Believe it or not, there are more than 1 million submarine volcanoes quietly churning lava beneath the waves as you watch this. The ocean floor is Earth's biggest volcanic hotspot. What makes axial seamount so thrilling is that it's under intense scientific surveillance, unlike any other underwater volcano. It's like the star player in a volcanic reality show, with a network of ocean-bottom instruments giving researchers real-time updates on magma movements, seismic tremors, and crust deformation. In fact, Axial Seamount hosts the world's first-ever underwater volcanic laboratory. Scientists have been keeping a constant eye on it since the 1990s, when they installed sensors that now relay live data straight from the seafloor. This kind of monitoring is unheard of elsewhere and has turned Axial into a geological celebrity, one whose behavior we can track with remarkable precision. Besides, Axial is hilariously predictable. It erupts roughly every decade, and right on cue, it's gearing up for another performance. By mid-2024, it had inflated to nearly the same level as before its last eruption, which means the countdown is on. Scientists are so confident in its schedule that they've set up a volcanic advent calendar, waiting for the day when Axial decides to pop. But hold on, Axial Seamount isn't just your average underwater volcano. It's got style, personality, and a geological identity of its own. Now, most underwater volcanoes, called seamounts, tend to look like cones or flattened domes. Axial laughs in the face of tradition with its unfashionably rectangular caldera, a 2-by-5-mile crater that looks like it was designed by a geologist with a ruler and a grudge against curves. Most volcanoes opt for the classic circular look, but Axial, it went full avant-garde. This caldera is punctuated by fissures, vents, lava channels, and mysterious dome-like structures that rise hundreds of feet high. It's like the volcano's wearing a funky geometrical crown instead of the usual rounded hat. What's more, Axial's location is like prime real estate for geological fireworks. It sits right where two major forces collide, literally. First, it's on the Juan de Fuca Ridge, an underwater mountain range formed where two tectonic plates are slowly pulling apart, like a zipper being undone. Second, it's perched atop the Cobb Hotspot, a deep mantle plume that acts like Earth's sneaky magma espresso machine, pumping molten rock from deep inside the planet and fueling a whole chain of seamounts. To put it plainly, it's like the tectonic plates are reluctant dance partners, sliding away from each other, while the Cobb Hotspot acts as the DJ, turning up the heat and keeping the magma party going. This dual influence creates a complex plumbing system inside the volcano, with magma chambers filling, draining, and shifting in ways scientists are still trying to decode. The competition between the spreading plates and upwelling magma is what gives Axial its unique geological fingerprint, and it's also why this volcano keeps surprising us. Now, we said that Axial's summit isn't just a crater. The truth is that inside, the action gets even weirder and cooler, well, hotter, but you get it. Axial hosts black smoker hydrothermal vents, which blast superheated water at temperatures exceeding 700 degrees Fahrenheit. This is no ordinary underwater hot tub. These vents create one of Earth's most extreme environments, where bizarre creatures thrive in total darkness and scalding heat. Giant tube worms, crabs, colonies of bacteria, and even octopuses live off the mineral-rich plumes that gush from these vents, forming ecosystems completely independent from sunlight and photosynthesis. It's like an alien world beneath the waves, thriving off the volcano's fiery breath. These vent communities are crucial to science, not just because they're strange, but because they may resemble the earliest ecosystems on Earth. Some researchers believe life on our planet may have originated in similar deep-sea hydrothermal environments billions of years ago. Studying them could also help us search for life on icy moons, like Europa and Enceladus, where similar vents might exist beneath their frozen surfaces. When Axial erupts, it's like a natural reset button for these communities. The lava wipes everything out, but within months, life comes roaring back. Proof that even in the most hostile environments, real estate is always in demand. For those worrying about tsunamis or coastal disasters, relax. Axial's eruptions are the underwater equivalent of a slow cooker. The immense water pressure keeps things chill, well, scalding, but not explosive. So the worst thing that happens is some lava decorates the seafloor, and a few crabs have to find new vents to squat in. This means no massive ash clouds or explosive blasts that could reach the surface. Instead, lava oozes out and spreads across the seafloor, sometimes traveling for miles. But for scientists, this eruption is the golden ticket. Understanding Axial's patterns could help predict eruptions elsewhere, even on land. Plus, its bizarre ecosystems offer clues about how life might survive on other planets. Not bad for a volcano that mostly just sits around looking rectangular. Still, the volcano's activity can be heard in the form of thousands of small earthquakes every day. Thousands! As if the volcano itself was groaning and creaking, preparing to burst open. Again, we won't feel a thing, but at least they'll help scientists track the magma's movements and the volcano's eruptive cycle. Now, one of the coolest parts of this story is that scientists are preparing to live-stream Axial's next eruption for the first time ever. Imagine watching an undersea volcano in action, live, as it's painting the ocean floor with fresh lava. It's like a front-row seat to a natural fireworks display, thousands of feet beneath the waves. The livestream will come courtesy of the Ocean Observatory's initiative, which maintains a series of fiber optic cables linking Axial's instruments directly to shore. It's the Wi-Fi of the deep sea, and it's about to broadcast molten rock in HD. And there's another twist. Scientists have noticed a curious pattern in Axial's eruptions. All three of its most recent eruptions, in 1998, 2011, and 2015, happened between January and April, the months when Earth starts moving away from the Sun. So why? Well, it might have something to do with the Moon's gravitational pull. The Moon's orbit causes ocean tides to rise and fall, which changes the pressure on the seafloor and could help nudge the magma chamber to its breaking point. I guess the Moon isn't just a romantic light in the night sky. It might be the ultimate volcanic whisperer. So, one thing's for sure, when Axial goes, it'll be the best documented underwater eruption in history. So, keep your eyes peeled. This is one natural spectacle you won't want to miss. And who knows, if we're lucky, we might even get deep-sea eruption ASMR out of the deal. Now, if you'll excuse me, I'll be refreshing the live feed like it's a Taylor Swift ticket sale.
The ground suddenly starts shaking. Clouds of gas start forming in the sky, making it dark during broad daylight. Bits of the ground start swelling, lifting, and even collapsing. These are the telltale signs of a volcano that is bound to erupt. And this is what could easily happen again with Mount Spur. It's only about 75 miles from Anchorage, one of Alaska's busiest cities. More than half of the population of the northernmost state of the US live there. There's also a huge amount of air cargo that passes through its international airport daily. So anytime a volcano this close to such a vital hub begins to get restless, people start paying attention. Just FYI, approximately 350 million people in the world live within the danger range of an active volcano. That means that around 1 out of 20 people live in an area at risk of volcanic activity. Alaskans probably wish that Spur's reawakening was fiction, but it's actually true. The Alaska Volcano Observatory picked up on several of these "I'm about to erupt" signs from Mount Spur. So much so that they raised the alert level to yellow, which means unrest above normal background levels. Spur erupted twice in the 90s, and it was pretty intense. If we were ranking volcanic eruptions on a scale from 1 to 10, these eruptions would rank a 6 or 7. Not that terrible, but still worth 10 to 17 million in damages. However, these numbers are nothing compared to Alaska's 1988 Redoubt eruption, another volcano that erupted and summed up a staggering $345 million in damages. Mainly because its ashes hit aircraft engines, such as the KLM 747 that lost power after all its engines went off due to the ashes. If people weren't paying attention to Alaska's unstable geology before that, well, they surely started to after it. When you think of the hazards of volcanic activity, the first thing that might possibly pop in your mind is Pompeii, Italy. Of course, that's the worst-case scenario, a city being engulfed by lava. Spur may seem innocent compared to Vesuvio, but it still took its toll. The last time it erupted in the 90s, and it threw volcanic aerosols over 60,000 feet into the atmosphere. Let's get our science straight here. Think of volcanic aerosols like liquid particles that are released into the atmosphere during an eruption. These particles are usually created when gases from a volcano, such as sulfur dioxide, combine with water and other particles that exist in our atmosphere. These aerosols can actually cool the Earth's surface since they reflect sunlight directly back into space. And that's not the worst part. It can stay in the atmosphere for several years after an eruption, causing lots of health issues. The eruption unleashed blazing fast avalanches of hot gas and ash called pyroclastic flows, along with thick, muddy floods known as lahars. Oh, and there were also the massive volcanic boulders. These rock chunks were huge, some over 3 feet long, and they blasted out from the volcano like nature's cannonballs, landing more than 6 miles away. All that volcanic heat melted part of a nearby glacier, kicking off debris flows that dammed up the Chakachatna River and created a whole new lake along the valley. Some good came out of Spur's first eruption, though. The main lesson was, volcanic monitoring pays off. The local monitoring was able to reduce the economic damage done by the eruption, especially for a city that has an intense air traffic. Spur is deemed as dormant for the moment, but it could go off anytime soon. You see, volcanoes are classified as active, dormant, or extinct, depending on how much action they're putting on. If it's still active, it's still rumbling and erupting somewhat regularly. Dormant means it's had some recent activity, but it's still lying low for now. And extinct, that's when it's been quiet for such a long time that we figure it's done for good. One of the US's most dangerous active volcanoes is Mount St. Helens. This volcano is actually responsible for the most powerful eruption in US history. Its last blast was so intense, it threw off about 1,300 feet off its summit. Basically, the top of the mountain vanished, and if you thought Mount Spur's ash cloud was impressive, St. Helens wins the competition since it launched its ashes 80,000 feet into the sky. Eastern Washington plunged into total darkness. But it wasn't just that. In a matter of 3 minutes, the eruption hurled 3.7 billion cubic yards of blazing rock and dust, enough to fill 1 million Olympic-sized pools across 230 square miles of lush forest. Actually, the earthquakes that anticipated the eruption started weeks before May 18, 1980. A ground shake of magnitude 5.0 went off, triggering a landslide on one side of the volcano. By the end of the official eruption date, 57 people had lost their lives. Nearly 7,000 big game animals like deer and elk were wiped out, and millions of birds laid scattered on the burnt earth. Researchers don't think St. Helens will blow at the same magnitude again anytime soon, but they're keeping an eye on it, because this volcano is not exactly finished. By the way, the word volcano comes from the Roman name Vulcan, which was the Roman deity of fire, and they often happen at the meeting point of tectonic plates, which are the pieces of the Earth's surface that fit together like a jigsaw puzzle. The so-called Ring of Fire, located in the Pacific Ocean, is the world's danger zone when it comes to volcanoes. It contains between 750 and 915 active volcanoes. The largest volcano located in the Ring of Fire, also the largest active volcano in the world, is the Mauna Loa. It's over 13,000 feet high, and it's located in Hawaii. Researchers say that Mauna Loa has been erupting for at least 700,000 years. Its most recent eruption began on the 27th of November 2022, and it lasted until December 13th. It's been quiet since the 80s until it decided to wake up again. Thanks to constant monitoring by the Hawaiian Volcano Observatory, it didn't cause any casualties when it last erupted. Scientists have been investing big time on volcanic monitoring, not only to reduce economic hazards, but also to save lives. The most recent attempt has been to drill into volcanoes. Recently, a group of scientists went all the way to Iceland in one of the world's volcanic hotspots. There are around 33 active volcanoes in Iceland alone, but the one that is the most interesting to them the most is the Krafla volcano. The Krafla has erupted around 30 times in the last 1,000 years, and its most recent eruption was in the mid-1980s. The project named Krafla Magma Testbed, or KMT for short, is hoping to advance the understanding of how magma behaves underground. The main advantage of this drilling research is predicting the risk of eruptions, but it can also help to push geothermal energy forward. I mean, can you imagine having electricity that is run by the limitless source of volcano power? The KMT team will begin drilling holes deep into volcanic ground in 2027. They're aiming at reaching over a mile into the ground. After all, it's different to monitor lava activity when it's on the surface than when it is still below ground. This will allow researchers to listen to the pulse of the Earth, according to them. They're saying this research is as revolutionary as the first time man went to the moon. Oh, and speaking of that, I was shocked to discover that volcanoes exist all throughout the solar system. Yep, other planets and moons have volcanoes too. The largest volcano in our solar system is Olympus Mons on Mars. It's a shield volcano, much like the ones that make up the Hawaiian Islands. It's about 370 miles wide. If we transported it all the way back to Earth, it would almost occupy all of Poland. Yikes.
These ominous rumbling sounds, the ground shaking under your feet. Wait a minute, that's my tummy. Or it might be Washington State's Mount Adams waking up. It's the largest volcano in the state by both area and volume, and it's recently started to show signs of life after staying silent for thousands of years. Scientists have noticed an alarming uptick in seismic activity around the mountain. And since the last eruption here happened between 3,800 and 7,600 years ago, humanity was still in the Stone Age at that time. This sudden chattiness has scientists, let's say, curious. The U.S. Geological Survey has hurriedly installed temporary seismic stations around Mount Adams to keep an eye on the situation. At the same time, they reassure the public there's no need to panic. Mount Adams doesn't reach the height of the better-known Mount Rainier, and still it covers a massive area, making it Washington's largest active volcano. Interestingly, records show that before September of this year, Mount Adams had experienced an average of just one small earthquake every 2 to 3 years since 1982. And then, the Cascades Volcano Observatory and the Pacific Northwest Seismic Network detected a staggering 6 earthquakes in just 1 month, September. These quakes were all rather tiny, with magnitudes ranging between 0.9 and 2 on the Richter scale. It means they were so weak you wouldn't feel them at the surface. Plus, satellite imagery confirmed there was no ground deformation in the area. Now, at the moment, the USGS keeps Mount Adams' alert level at green or normal, so we shouldn't worry about the ground opening and swallowing towns and cities. But the most recent seismic blips have encouraged the agency to install additional equipment for more precise monitoring. Such an expanded network will help scientists notice even the smallest earthquakes, which will help them understand what's happening under Mount Adams. This extra equipment might also shed light on whether this recent activity is a signal of future eruptions or just a random anomaly. If Mount Adams eventually erupted, it would likely produce slow-moving lava flows rather than explosive eruptions like Mount St. Helens. After all, past eruptions have only led to lava flows that travel just a few miles from the volcano. So that's not what we'd need to worry about. A much more dangerous thing would be lahars. These are mud flows that can happen when volcanic ash, rock, and melted ice mix during eruptions. Lahars have occurred near Mount Adams without even eruptions. Rock, weakened by hydrothermal processes at the volcano's summit, suddenly broke loose, creating fast-moving, destructive mud flows. Exactly for this reason, the USGS categorizes Mount Adams as a high-threat volcano. While it doesn't erupt frequently, it still poses serious risks to nearby settlements. Another volcano we should carefully watch is Katla in Iceland. It's one of the country's most powerful and dangerous volcanoes. It last erupted over a century ago in 1918, but if it erupts again, it could be 10 times as powerful as another Icelandic volcano whose name I can't pronounce. See? That one erupted in 2010, completely disrupting air travel all over Europe. An eruption of Katla could release large amounts of sulfur dioxide, which could form sulfate aerosols in the atmosphere. Such aerosols reflect sunlight, which could even cause temporary global cooling. This phenomenon often followed catastrophic volcanic eruptions in the past. Although eruptions are common in Iceland, Katla's ash cloud would likely shoot higher into the sky and cover larger areas of Europe than that other one did. It would ground flights and negatively affect economies. If Katla erupted, it would also harm agriculture, water supplies, and air quality. In 2014, scientists noted that a large eruption could even cause a tsunami, that might travel along Iceland's south coast and out to sea. But the potential impact of such a tsunami is still unclear. Katla tends to erupt on a regular schedule every 40 to 80 years, which means that another eruption is statistically very likely soon. That's why Katla remains under close scientific observation. The Canary Islands' Cumbre Vieja erupted recently in 2021, reminding people of its destructive potential. The lava flow from this eruption was devastating. It covered whole neighborhoods and flowed into the ocean, destroying more than 3,000 homes. Thousands of people had to be evacuated. But the craziest thing? Even though the damage was significant, scientists believe it could have been far worse. A massive eruption of Cumbre Vieja could have caused the volcano's entire western flank to collapse into the Atlantic Ocean, triggering a mega tsunami. This hypothetical tsunami could have potentially created waves hundreds or even thousands of feet high. They could have flooded coastlines around the Atlantic Basin, including parts of the US and Europe. Luckily, recent studies claim that a collapse of that scale is unlikely. But even though the chance of a mega tsunami is low, scientists still think it's wise to prepare for possible eruptions because there's a chance of extensive damage. The lava flows that occur at this volcano tend to be extensive and dangerous to both human life and the infrastructure on the island. If you decide to travel to Ecuador, you should be wary of Cotopaxi, one of the most active volcanoes in this country. It's been rumbling with minor eruptions since 2022. While these eruptions have been relatively small, Cotopaxi has a great potential for a major eruption, and it has scientists on high alert. If Cotopaxi erupted on a large scale, it could produce a massive ash cloud over 12 miles high, threatening the lives of around 200,000 people in the neighboring area. A serious danger is Cotopaxi's snow-capped summit. It would melt super rapidly in a major eruption. It could lead to destructive floods and landslides that would flow down the mountain and potentially reach populated areas. This combination of volcanic activity and glacial floods makes Cotopaxi a high-risk volcano. A powerful eruption could occur soon, or it could be years or even decades away. But monitoring efforts are in place to catch any warning signs. The next volcano we should watch out for is already infamous, Mount Vesuvius. Its catastrophic eruption in 79 CE destroyed the Roman cities of Pompeii and Herculaneum. Its last eruption occurred in 1944, but Vesuvius remains highly active and poses a great risk to nearby Naples, one of Italy's largest cities. A large eruption would threaten over 3 million people. Many of them live in the vicinity or even directly on the slopes of the volcano. If Vesuvius erupted, it would be an explosive event, with ash, rocks, and volcanic gas ejected at extremely high speeds. And even though such a destructive event isn't expected for a few hundred years, Vesuvius remains one of the world's most closely watched volcanoes. After all, it has a real potential to cause catastrophic damage in a densely populated area. Then, we have Popocatépetl, often called El Popo. It's one of North America's tallest active volcanoes, which lies about 40 miles from Mexico City. Exactly this proximity to a metropolitan area with a population of 22 million people makes Popocatépetl especially hazardous. A large eruption could send a massive ash cloud over Mexico City, causing widespread disruptions. Ash could clog the city's drainage systems, contaminate water supplies, and even cause power outages by short-circuiting electrical systems. Plus, lahars could rush down the volcano, reaching nearby towns. Popocatépetl has been showing near-constant seismic activity since the early 2000s, and smaller eruptions are pretty common here. In early 2024, there were 13 recorded minor eruptions, which alarmed nearby towns. At the same time, volcanologists consider such eruptions normal for Popocatépetl. While talking about super dangerous volcanoes, we can't skip Yellowstone National Park. It houses one of the world's largest supervolcanoes. Its last massive eruption occurred about 640,000 years ago. But if this monster were to erupt today, The impact would be much more devastating for the entire planet. States closest to Yellowstone, including Montana, Idaho, and Wyoming, would be most affected, likely experiencing disastrous pyroclastic flows. These flows, which are made of a dangerous mix of lava, ash, and gases, can obliterate everything in their path. Large parts of the country would also be blanketed in volcanic ash, over 3 feet in some areas. On a global scale, an eruption at Yellowstone would send tons of ash and gases into the stratosphere, potentially blocking sunlight and causing global temperatures to drop for a few years. This would disrupt agriculture, collapse transportation systems, and create food shortages on a massive scale. Still, even though there's a popular myth that Yellowstone is overdue for an eruption, geologists clarify that this isn't true. Volcanoes don't follow precise timetables, and the activity at Yellowstone doesn't indicate an imminent eruption. So yeah, that's good news. Guess what? A huge ocean might be hidden deep beneath us, about 250 to 400 miles down, and it's bigger than any ocean on Earth's surface. Scientists were listening to earthquakes deep within our planet and noticed how these shakes slowed down when passing through certain parts of the mantle. This suggested that water was there. Models and experiments led them to uncover the underground ocean. But this ocean isn't like the typical water you imagine. It's a lot crazier. The mantle is a thick layer between the Earth's crust and core. It consists of the upper mantle, the lower mantle, and a mysterious layer between them called the transition zone. In the upper layer, we can often find a fascinating material called olivine, which got its name from a pretty greenish color. Olivine doesn't care about high temperatures and thrives in lava comfortably. It not only thrives, but it even makes up 50% of the entire upper mantle. We can find this stuff on Earth thanks to volcanoes. When volcanoes spew their magma out, all the minerals in it make their way to the surface. As magma cools and solidifies, it forms igneous rocks, and the minerals start to crystallize. Olivine is one of the first minerals to crystallize, and since there's so much of it in magma, it forms lots of crystals. Sometimes they're small, but sometimes they grow large and become very noticeable. We collect these large gemstones and use them to make pretty accessories and for other purposes, such as casting metals. But as we dive deeper within the Earth, about 250 miles down, things get strange for olivine. We enter the mysterious transition zone. The pressures get way higher, and the temperatures rise significantly. Here, olivine transforms into beautiful rock called wadsleyite and ringwoodite. Just like with olivine, we sometimes find them thanks to volcanic activity. Both are blue-green with a beautiful glassy appearance. Unfortunately, they're exceedingly rare and small, so you can't make accessories out of them. They're usually studied in labs. But they can do something that olivine can't. Thanks to their structure, they can act like a sponge, soaking up water. Now, this doesn't mean that they're literally wet. Rather, wadsleyite and ringwoodite can store water components, hydrogen and oxygen, within their structure. Usually, up to about 3% of them are water particles. These two little guys play an immense role in our planet's geology. They influence how the Earth's mantle conducts electricity as well as its viscosity, or how well it flows. This affects mantle convection, plate tectonics, and even volcanic activity. Without these tiny crystals, our planet would be completely different. The world could be mostly underwater, with just a few mountaintops visible. They also help us better understand how water works in general. So the transition zone is special because it's hydrated. Here we come to the recent discovery, a massive underground water reservoir. Scientists try to understand how water behaves in this deep part of the Earth. They discovered that as water-rich ringwoodite moves even deeper into the Earth to the lower mantle, it can start to melt a bit. This means it can release a bit of water and then trap it somewhere underground instead of letting it move around freely. But this released water wouldn't really be in its liquid, solid, or gas forms. Instead, it would be chemically bound to the underground structures. So, It won't be an ocean in the traditional sense, but there might be a vast amount of water down there. This finding is super important because it changes the way we understand Earth's water cycle and resources. It turns out that water isn't just found on the surface, but also moves through hidden spaces deep inside the planet. Another fascinating thing we discovered about water is that it might exist in a mysterious fourth state of matter. Now, we're used to thinking of water in its three common states: solid, liquid, and gas. But under extreme pressure in tiny spaces, it can enter a mysterious fourth state known as tunneling. We discovered this strange behavior in the mineral called beryl. Within beryl, there are super small six-sided channels, just about 5 atoms across. Turns out these channels act like tiny cages that can trap individual water molecules, like wadsleyite and ringwoodite. In these conditions, the water molecules start showing behaviors that are closer not to classical physics, but to quantum physics. Quantum tunneling allows particles to exist in multiple places at once or pass through barriers they shouldn't be able to. Imagine a ball that somehow ends up on the other side of a hill without climbing over it. It just goes through the hill. Hydrogen atoms in beryl are like tiny balls. Typically, each ball would sit in one specific spot. However, in the experiment, these hydrogen atoms didn't stay still. Instead, they were found simultaneously in multiple spots. Together, they formed a pattern that looked like 2 wavy rings. It's like water molecules got smeared around in a ring shape. This is a state of water that we've never seen before. It reshapes our understanding of how water behaves under certain conditions, and it has huge implications for biology. All these discoveries have everyone rethinking where Earth's water really comes from. Water is essential for life as we know it. About 71% of Earth is drenched in water, and humans are mostly water too. When we figure out how it appears in space and on planets, it will give us clues about how to better search for extraterrestrial life. One theory says that when Earth was forming, the materials that clumped together to make the planet already included water, or at least the ingredients to make it. Earth formed about 4.5 billion years ago. Our planet slowly emerged thanks to gravity from dust, gas, and rocks that surrounded our newborn sun. This material gradually came together to form the planets of our solar system. However, the young inner solar system was a scorching place, too hot for any liquid water to survive. It would have simply vaporized and escaped into space. But it's possible that water was trapped inside the rocks that initially formed Earth. Some of the Earth's original building block contained much more hydrogen than all our oceans combined. It would also explain how water molecules got so deep underground. Then, volcanic activity could have later released the water stored deep within, sending it into the atmosphere as vapor. This vapor would eventually cool down, condense, and fall as rain, filling the young Earth with lakes and seas. Another idea is that after Earth was formed, water was brought here by wet space visitors like comets and asteroids crashing into the planet. Long ago, the inner solar system was a wild and chaotic place, much like Brightside. When the outer planets rearranged their orbits, this caused a ripple effect, which we now call the Late Heavy Bombardment. It sent a flurry of icy space rocks crashing through the inner solar system, many of which collided with Earth. For a while, scientists thought that this event and comets were a primary source of Earth's water. But then, we learned that comets have a different chemical makeup from the water on Earth. Then we looked at the asteroids. Their water closely resembles the water in Earth's oceans. Some of the samples even contained organic materials. There's also a chance some random planet helped us out. About 4.5 billion years ago, a Mars-sized planet named Theia is thought to have collided with Earth. It was a violent encounter that melted part of Earth's mantle and led to the formation of the Moon. Perhaps Theia also brought some water with it. And finally, Earth could have generated its own water. Chemistry says that hydrogen could react with molten rock in vast magma oceans to produce seas and oceans. It's also possible that all these ideas are true, and Earth's water came from several sources. It complicates our research, but shows how dynamic water can be in space. Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980, and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
Phew, you could finally send that last report for the day and breathe out. The weekend is around the corner, but just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though. Let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon, the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco volcanic field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco volcanic field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco volcanic field will remain a hidden gem of volcanic history, waiting for its next fiery performance.
Okay, watch your step now. Millions of gallons of hot magma are gathering in one flow and rising thousands of miles to the surface of our planet. A massive fracture in a tectonic plate shakes the ground and fills the air with a loud hum. Fire, gases, lava erupt from the dark, unexplored depths of Earth's crust. A planetary-scale catastrophe has just happened, and no one's noticed it. Now imagine you're having fun on a luxury yacht somewhere in the southwestern Pacific Ocean, drinking cocktails and sunbathing. At this moment, one of the most powerful volcanic eruptions in the planet's history is happening right below you. But you don't feel anything. You don't even drop your glass. Yeah, you can hear a strange sound coming from the ocean depths. You see foaming water and pieces of pumice floating up to the surface. But it doesn't bother you much. So how did it happen that we missed such a powerful eruption in 2012? Why did scientists find out about it only a few years later? The answer is simple: water. An eruption of an ordinary volcano is a huge disaster. There are incandescent liquid metals and molten rock containing almost the entire periodic table inside our planet. All of this soup is called magma, and it's constantly boiling inside the subsoil of our world. This hot substance is lighter than the surrounding crust, so it always rises. Fortunately, the planet's surface is strong enough and doesn't allow magma to splash out. But sometimes this protection fails. The upper part of Earth is covered with connected parts, tectonic plates. These plates collide with each other and then move apart. Imagine a big moving mosaic puzzle where all its parts are tectonic plates. And when a small part of this puzzle gets separated from another, magma immediately comes up. These unstable fault sites with leaking magma are called volcanoes. And when they erupt, it gets hot. Lava flows out of the vent and burns all the vegetation around. This is accompanied by earthquakes and thick black smoke. If a volcano spits out magma too high, it falls back to the surface in the form of fire rain. But the worst thing here is ash. It's not that ash that's left in your grill after a good barbecue, no. Volcanic ash consists of solid particles harmful to any organism. These particles are not burnt wood, but various chemical elements. Volcanic ash is sharp, dense, and tangible. It can block sunlight, cover and destroy all plants, settle in your lungs. If you get too close to an erupting volcano, well, you better have a fireproof suit, oxygen tanks, a gas mask, and an underground shelter. Then you might survive, but there's no guarantee. At the same time, if an eruption occurs underwater, you don't need to worry about it. Of course, if you're not a marine biologist studying coral reefs nearby, or if you don't travel past that area in a submarine. In that case, boy, you're in trouble. When an underwater volcano erupts, this shakes a colossal area, heats the water, destroys the seabed. But almost nothing happens at the surface. The enormous pressure of millions of gallons of water suppresses the destructive power of the volcano. Molten rocks shooting out of Earth's crust get pressed against the seabed. Yeah, a submarine swimming by would be thrown off course and might collide with solidified lava. Fortunately, no such cases have ever been recorded, but it can easily become a reality because underwater eruptions happen pretty often. More than 70% of all volcanic activity occurs underwater, and almost no one notices it. In most cases, these volcanoes immediately fall asleep after they erupt and never wake up again. But in 2012, something happened, and scientists couldn't ignore it. Big pieces of pumice, the size of a van, began floating up in the southeastern Pacific Ocean. These rocks covered about 154 square miles. There were thousands of them. They looked like a group of unknown floating mini-islands. Volcanic stones were scattered in the ocean over the area twice as large as New Zealand. Scientists determined the full scale of the disaster with the help of deep-sea sonar devices. They studied the seabed at a depth of 4,000 feet for a long time and found 14 craters from which magma had flowed during the eruption. The seabed was covered with frozen lava flows and tons of ash. The researchers found that more than a third of the erupted volcanic material surfaced and was scattered all over the place. The rest remained at the bottom. This wiped out all marine life in the area. It seemed that this eruption was one of the largest in the entire history of observations. But in 2019, researchers discovered something even more significant. That was an underwater volcano 3 times higher than the Eiffel Tower. According to scientists' calculations, it ejected between 30 and 1,000 times more molten rock than the previous volcano. This monster had been feeding from the world's deepest magma reservoir we know about. Seismic activity here was so devastating that it destroyed everything around. Fortunately, not for long. After any eruption, life reappears like a phoenix rises from the ashes. And it's not just a figure of speech. Volcanic ash and lava around the volcano contain many useful mineral elements. All of them nourish the soil and help microorganisms develop on land and in the water. For this reason, there's usually so much vegetation, flowers, and trees around volcanoes. And underwater volcanoes can eventually form islands. This is a long process that ends with the appearance of a massive piece of land above the water surface. To understand how this happens, you need to go back millions of years. So, let's go. See this underwater volcano? There are sea dinosaurs, giant sharks, and ancient fish swimming around. Now, the seabed starts shaking. The volcano releases tons of magma and ash. The water pressure immediately pushes all this stuff back to the bottom. The eruption can continue for a long time. The released magma raises the seabed. After hundreds, maybe 1,000 years, a new eruption begins. New magma flows create a new layer above the previous one. Over millions of years, layer by layer, the volcano is growing. It's slowly rising, thanks to constant eruptions. Of course, with time, some volcanoes go dormant, but this one continues to erupt. And then, one day, the volcanic rock reaches the surface and an island emerges. After many more years, the volcano can fall asleep. After this, life is likely to appear on the island. Grass, flowers, trees, animals. The area that was once ruined seabed is swarming with life now. Volcanic islands have unique ecosystems because they develop separately from all the continents. Observing such islands helps scientists understand how life on Earth evolves. New species of birds, animals, insects can live on these chunks of land. Hundreds of islands around the world appeared thanks to eruptions of underwater volcanoes. You can find them in Hawaii, Indonesia, Iceland. Many of them are inhabited by people who build villages and towns there. There were cases when a volcano erupted when people literally lived on top of it. That's what happened on the small island of Aogashima, located to the south of Tokyo. People built a beautiful town right in the crater of an active volcano. And in May 1785, an eruption began. Nobody expected this to happen. At some point, thousands of birds rose in the air and flew away from the island. Then the ground began to shake. A heavy, low sound shook the air. Thick smoke appeared above the top of the green volcano. The crater started spitting dirt, huge rocks, and red-hot pieces of magma into the sky. The disaster lasted several weeks. People somehow managed to evacuate. Then, finally, the volcano calmed down. After that, a long process of recovery started. The inhabitants of the town rebuilt houses, roads, infrastructure. More than 200 years have passed since that moment, and during this time, the volcano never woke up. And despite the risk of a new eruption, people continue living there. The population is growing. Many people from other cities and countries come to live there. The main reason everyone loves this place is that it looks like a paradise. Nobody wants to leave the island. There are thermal springs where you can bathe, dense jungle with many beautiful animals and trees. The soil is rich, and you can grow tasty fruit and vegetables there. The water near the coast is swarming with fish. Every day, you can enjoy the incredible landscapes of the island. Seismological services constantly monitor the situation and watch the volcano's activity, listening for a rumble that may someday come again. Shh! The planets and the moons in our solar system are hiding secrets that could change our knowledge of Earth itself. Uranus stores heat we didn't expect. Mercury has been shrinking and cracking for billions of years. Jupiter's moon, Io, emits giant columns of volcanic plumes. These cosmic mysteries hint at forces and processes that could, one day, ripple through the solar system and even affect life here on our own planet. Back in 1986, Voyager 2 flew by Uranus and confused everybody. The readings showed the planet wasn't giving off any extra heat. This made it look totally different from the other giant planets in the solar system. That was strange because Jupiter, Saturn, and Neptune all release way more heat than they take in from the Sun. Fast forward a few decades, and two independent research teams went back through a mountain of observations. What they found changes the story. Uranus does give off more heat than it receives. About 12.5% more to be exact. The two studies show that Uranus is still slowly releasing leftover heat from its early days. That detail matters greatly because it helps scientists piece together the planet's origins and how it's changed over time. As for Voyager 2's odd readings, they now make more sense too. The flyby happened when the Sun was unusually active, which made Uranus act weird. So those early numbers likely didn't reflect its normal state. Even so, Uranus still stands out. Jupiter pushes out 113% more heat. Saturn gives off 139% more, and Neptune tops them all at 162%. And since Neptune is farther away from the Sun, distance isn't the reason Uranus is cooler. Something unique is happening deep inside. Maybe the planet's structure is different, or maybe its past somehow shaped it in another way. Another weird space body in our solar system is Jupiter's moon Io. Oh, by the way, did you know that Io has a brother moon named EIE? So, through a telescope looking at Jupiter, you can sometimes see them. EIE, Io. Right next to Old MacDonald. Hey, I thought it was funny. Anyway, back in 1979, Voyager 1 zipped past Io and saw something jaw-dropping. Giant volcanic plumes were blasting straight into space. It was the first time humans had ever seen active volcanism beyond Earth. Io looked wild, and ever since then, scientists have been trying to figure out what makes this little moon so ridiculously volcanic. For decades, one leading idea was that Io hid a global magma ocean just under its crust. That would explain why volcanoes are scattered pretty evenly all over the surface, as if they're feeding off the same underground reservoir of molten rock. NASA's Galileo spacecraft even seemed to back this up in the 1990s and early 2000s. Its magnetometer picked up a weird magnetic signal that looked like it came from a huge electrically conductive layer, basically liquid rock. By 2011, the consensus was that Io was sitting on a magma ocean several dozen miles thick. But now that theory has been flipped on its head. NASA's Juno spacecraft has been looping around Jupiter since 2016, and in late 2023 and early 2024, it made a couple of super close flybys of Io. The main goal was to figure out what was going on inside. Juno carries a super precise radio transponder that scientists use like a stethoscope. Io's gravity field tugs on the spacecraft ever so slightly, changing the radio signal. By mapping those tiny shifts, the team can see how mass is distributed inside Io. The verdict is, there's no shallow magma ocean sloshing under the crust. Otherwise, Juno would have picked up way more distortion in Io's gravity field as Jupiter's tidal pull flexed the moon. But the data showed nothing of the sort. This leaves planetary scientists with a big puzzle. If there's no magma ocean, what's powering the most volcanically active body in the solar system? Io's volcanism is likely driven by tidal heating, because Io's orbit is a little stretched out by the gravitational tugs of neighboring moons. Jupiter constantly squeezes and releases this little world. The crust can rise and fall by as much as 330 feet, and all that flexing creates frictional heat inside the moon. Tidal heating does make magma, but if it's not pulling into a giant ocean, maybe it's stored in smaller scattered reservoirs within the crust. On Earth, different magma chambers feed different styles of volcanoes, but since Io doesn't have plate tectonics, it probably doesn't have the same variety. The new results don't totally rule out a deep magma ocean buried way below the crust. But if that exists, it would be so dense and iron-rich that it wouldn't rise easily to the surface. At that point, it's hard to tell whether we'd even call it a magma ocean or just a molten core. Now, at the same time, Jupiter's moon Europa, for example, is also tidally heated, but in its case, the heat likely sustains a salty liquid water ocean beneath an icy shell. Saturn's moon Enceladus is another great case. The Cassini spacecraft not only found signs of a hidden ocean, but even flew through plumes of water erupting from its south pole. So why does tidal heating make water oceans on some moons, but not magma oceans on Io? The thing is, magma is lighter than solid rock, so it wants to rise and erupt quickly instead of sticking around in one giant pool. Water, on the other hand, is heavier than ice, so it sinks and collects into a stable ocean beneath the crust. That's why magma oceans are so hard to sustain, while water oceans are relatively easy. In any case, even though tidal heating may not be great at making magma oceans, it's excellent at making water oceans. And since water is the key ingredient for life, moons across the solar system, Europa, Enceladus, and maybe others too, could be hiding habitable environments beneath their icy crusts. Io might be a volcanic inferno, but it's helping scientists figure out where else we might actually find life in our solar system. Now, let's move closer to Earth and explore Mercury. Believe it or not, this planet and our favorite pastries have something in common. They both shrink as they cool. Mercury formed about 4.5 billion years ago, and ever since then, it's been slowly losing heat. As the planet cools, its rocky shell contracts, just like a cheesecake or cookie that cracks when it comes out of the oven. Mercury develops fractures in its crust. These show up as thrust faults, giant cracks that push up sections of the planet's surface to make room for its shrinking interior. By looking at how those faults have lifted up Mercury's terrain, scientists can figure out how much the planet has shrunk over time. But earlier estimates were all over the place, ranging anywhere from less than a mile to more than 4 miles of lost radius. That's a pretty big range. So figuring out a more precise number has been a long-standing puzzle. To tackle the problem, researchers tried a new way of measuring Mercury's shrinkage. The old method used the length and height of uplifted landforms, but the results shifted depending on how many faults you counted in the dataset. More faults, one answer. fewer faults a different answer. That inconsistency made things messy. The new method avoids that issue. Instead of relying on every single fault, it focuses on the biggest one in the set. It's like finding the biggest crack in a cookie and using it as a baseline to estimate how much the whole thing cooled and contracted. Now, to test this, the researchers ran their method on 3 separate datasets. One had 5,900 faults, another had 650 faults, and the last one had just 100. And no matter which dataset they used, the results stayed consistent. Mercury has likely shrunk by about 1.2 to 2.1 miles due to faulting alone. But the planet didn't just get smaller because of its cracks. Scientists added shrinkage from other cooling processes to their fault-based results and found that the planet has gotten up to 3.5 miles smaller since it first formed. These new numbers don't just show how much Mercury shrank, they also give clues about its thermal history. They tell us how fast it cooled, how its interior changed over time, and how its crust reacted to that cooling. And this method isn't just for Mercury either. Researchers think it could also be used to study tectonics on other planets, like Mars, which has faults on its surface too. So listen up. One day our sun will cool down and turn into a white dwarf. But this is not the worst thing for Earth. Before the star cools down, it will grow to an incredible size and arrange Ragnarok for us. Now, in case you don't know, Ragnarok is the fire apocalypse from Nordic mythology. So our star will burn down absolutely everything on our planet. But hey, don't worry, there's good news. This one day will come in 5 to 7 billion years. The bad news, though, is that almost all complex life on Earth will become extinct much sooner, maybe in 250 million years. But there's a small chance that our planet will be ruled by octopuses. Yeah, I know, this is too much news for the first few seconds. So let me break it all down for you, one thing at a time. We all hear about people destroying nature and polluting our planet. This is all true, but even without our intervention, the vast majority of living creatures on the planet will disappear, including ourselves. The reason is natural disasters and weather change. It sounds terrible, but it's not new to Earth. Scientists have found out that there have already been 5 mass extinctions. The last one happened about 65 million years ago, when dinosaurs disappeared. But life won anyway and took on many different forms. The 6th apocalypse may occur within the next 250 million years. Conditions on Earth at this time will be unsuitable for mammals because the level of carbon dioxide will be twice as high. This will happen because the sun will release 2.5% more radiation and it'll get too hot on Earth. The temperature in most parts of the planet will reach between 104 to 158 degrees Fahrenheit, and the entire land will turn into one supercontinent. In regions with high humidity, the temperature will be even higher, and of course, under such conditions, it will be difficult for people to walk in the park and play frisbee with dogs. No one will play with anyone at all. Let's hope we'll have colonized other planets by this time. Increasing solar fluxes will lead to a sharp loss of oxygen in the atmosphere. This means that in about 1 billion years, our Earth will look like the lifeless place it was about 2.5 billion years ago. That is, before the Great Oxidation Event. At that time, the air was filled with methane, carbon dioxide, and other gases. And the planet was inhabited by the simplest bacteria. Some of them learned how to make oxygen from sunlight and carbon dioxide. Throughout billions of years, they made so much oxygen that it became enough for the birth of new, more complex forms of life. And it seems we will return to these prehistoric times. Now, humans can't exist in such conditions, but some complex life forms hiding in the dark depths of the ocean might be able to adapt to the changed atmosphere and become the masters of Earth. These complex life forms are octopuses. There are many species of these animals. Some live in coastal areas, while others dwell in the deep waters of seas and oceans. And some species may be able to survive and create a new civilization. But why octopuses? Because they're some of the most intelligent creatures on Earth, and probably the most intelligent creatures among all the inhabitants of the dark depths. Octopuses can use surrounding objects as tools. For example, they can wear a coconut shell for protection or shelter. In laboratories, they've used various objects to complete mazes. These animals often escape from their water tanks to visit octopuses in nearby tanks. Yes, they have high intelligence, but not in the human sense. Their intelligence is more like a computer. You see, octopuses have neurons not only inside their brains, but also inside their 8 tentacles and large eyes. It's like a big data center, and their limbs sense the environment in exceptional detail, as if they were the brain. Not only their intelligence, but also their physiological properties might help the octopus survive if the apocalypse strikes. Its body has no skeleton. It can squeeze through any hole, slip past any obstacle, and their 8 highly developed limbs allow them to intelligently interact with their surroundings. Crows can bend pieces of wire with their beaks. They can throw stones into the water to raise the water level and get food. But they only have one beak. An octopus with its tentacles has at least 8 times more possibilities. They don't have spines, so they'll most likely build a civilization not on land but underwater, where it's much more convenient to move with such a body. To build a civilization, they'll need to find cheap energy. For example, hydrothermal underwater springs or tides in coastal areas. This will be a difficult task, but it won't be the most challenging thing for creating cities. It's very difficult for them to maintain social connections. By their nature, they are loners, who usually form groups of several individuals. But this is not enough to carry out large-scale construction of underwater urban areas. Parents pass on culture, history, upbringing, and moral guidelines to their children. They spend a lot of time and effort on education. Octopuses don't do this at all. The female octopus passes away shortly after laying eggs. The male octopus has only one mating relationship in its entire life and passes away shortly after the female is fertilized. So, in a sense, octopus cubs are born orphans. It's not surprising that it's difficult for them to build social connections. Over the past 50 to 100 million years, octopuses have not developed a collective feeling, and it's difficult to imagine that it will suddenly appear in the future. Perhaps something will encourage them. Who knows? Some scientists who study octopuses have noticed that over the past 10 years, some octopus species have shown certain social skills. Some live in groups of 10 or more individuals. If humanity doesn't ruin the lives of these animals by fishing and dumping garbage into the ocean, then they have a good chance of succeeding in conquering the planet. But if they fail, then the next candidates might be nematodes, those little white worms. Well, let's hope octopuses win. They seem cuter. They also may achieve a technological breakthrough much faster than we think, because when you have 8 arms, you work much better. Imagine these octopuses leaving Earth and flying to another galaxy, where they meet us humans. Do you think we could become friends? So let's say octopuses become a highly developed civilization that builds cities in the oceans. But they, just like humans, will have to think about colonizing other planets because of the upcoming Ragnarok. The sun keeps heating up and getting bigger, don't forget. Our star is currently in the most stable phase of its life. It has been in this phase for the last 4.5 billion years. But after another 5 billion years or so, the hydrogen in its core will start running out, and then the fun will begin. As hydrogen fusion slows, the core begins to contract. As the core gets smaller, it heats up until it can kick off another round of nuclear reactions, fusing helium into heavier elements such as carbon, nitrogen, and oxygen. Eventually, the sun will turn red and be so gigantic that it will swallow up Mercury, Venus, and possibly Earth. So, it may be Ragnarok not only for our planet, but for the whole solar system. No matter how tough octopuses are, they won't survive such a disaster. Earth is likely to burn down completely. Maybe it'll look like the moon, or it'll completely disappear. What will happen to the sun next? Its energy will run out sooner or later. Then it will shrink to the size of Earth and turn into a white dwarf. When a star goes out, it ejects a huge amount of gas and dust. Only the cooling core remains. All those outer layers will be floating in space, forming a beautiful nebula, and our solar system will become unrecognizable. Well, in some ways, it can sound pretty sad and scary, but hey, look at the bright side. Yeah, pun intended. It's going to happen in 5 to 7 billion years, so relax. Humanity has been living on Earth for about 40,000 years. If we compress the entire history of our planet into one 24-hour day, then the history of people will be equal to 1 second. If we achieve such a development in 40,000 years, what'll happen in 100,000 years, in 1,000,000 years, in 1,000,000,000 years? It's hard to predict. So how about going to the park and enjoying the sun at its best? Yeah, bring some sunscreen.
About 2 billion years ago, a massive asteroid crashed into Earth, leaving behind total destruction and what we now call the Resurfaced crater in South Africa. And get this space invader might have been way bigger than scientists originally thought, possibly twice the size of the asteroid that wiped out the dinosaurs. Nowadays, the Resurfaced crater is about 99 miles across, which makes it the biggest visible crater on Earth. But technically, it's still smaller than the Chicxulub crater in Mexico. The latter is about 112 miles, and it was left by the infamous dinosaur distractor 66 million years ago. But the thing is, craters don't stay the same forever. Over time, erosion wears them down. That's why they start looking smaller than they used to. And scientists think that when the Resurfaced crater first formed, it could actually reach 174 miles across. That means it was the biggest impact site Earth has ever seen, even though it looks smaller today. Just imagine how insane that impact must have been. A space rock that would have sent shockwaves ripping across the planet, triggered enormous wildfires, and completely changed the climate. The asteroid likely hit Earth at a very, very high speed. But since this catastrophe happened billions of years ago, way before dinosaurs or even complex life saw the light of day, it didn't wipe anything out like the Chicxulub asteroid did. At the same time, recently, researchers have realized that the asteroid might have been even bigger than they thought previously, up to 15.5 miles wide. As for the speed at which it slammed into Earth, it could reach a staggering 56,000 miles per hour. Now, figuring out how big Resurfaced originally was, that's been a bit of a headache. The main issue is that it's super old, and we're talking about 2 billion years old. No wonder that over that much time, erosion has kind of worn it down, so it's hard to tell just how huge it once was. But it's not just erosion causing the problem. Over the years, new layers of rock have built up over parts of the crater, and they've covered up most of the original structure. That's why now only little pieces of the raised rim are left, and this makes it even harder to get a clear idea of how big it was. So, scientists started looking at the minerals around the crater, like quartz and zircon. They discovered that those were all messed up by the asteroid's impact. They had tiny fractures caused by the blast. Researchers studied those damaged crystals and managed to figure out how far the explosion actually spread. Equipped by this new knowledge, scientists now believe that their latest estimates of the size of the asteroid are the most accurate ones. The reason why we haven't heard much about this disastrous impact is that, unlike the Chicxulub asteroid, which wiped out the dinosaurs and reshaped life on Earth, the Resurfaced asteroid hit at a time when Earth was a very different place. There were no trees, no animals, just single-celled life in the oceans. That means no mass extinction, no burning forests, no fossilized evidence of chaos. But scientists think it still had a massive impact on the planet. It might have changed the climate even more dramatically than the asteroid that ended dinosaurs. But since we don't have much direct evidence of the disaster, studying what's left of the Resurfaced crater is one of the only ways to understand just how powerful this impact was. Even though it happened billions of years ago, learning about this impact can help us understand the history of our planet, and maybe even prepare for future asteroid threats. After all, they could be similar to what happened in Siberia at the beginning of the 20th century, pretty recently. It was a warm morning, June 30th, 1908, when the sky suddenly lit up with a blinding flash. What followed was an explosion so powerful that it remained a mystery for decades. Known as the Tunguska event, it was one of the most baffling disasters in history. Scientists suspected an asteroid impact, similar to the one that wiped out the dinosaurs. But there was one eerie problem. No crater was ever found. The explosion struck deep in the remote forests of Siberia, near the Podkamennaya Tunguska River. The blast was beyond anything seen before, flattening around 80 million trees across an area of 830 square miles. The sheer force of the event was mind-boggling. It was strong enough to devastate the landscape, scorch the ground, and wipe out countless animals. According to witnesses, there was an eerie glow in the sky, which was followed by a streaking fireball with an intense bluish light. It was brighter than the sun. Moments later, there was a deafening blast. The shockwave was so powerful that it shattered windows hundreds of miles away, and people were knocked off their feet. Yet, despite the destruction, the source of the explosion left no obvious trace. Later, scientists finally started to understand what had occurred on that day. Imagine a meteoroid racing into Earth's atmosphere, transforming into a blazing meteor. It's traveling so fast that the air in front of it compresses and heats up, setting it on fire. But it's so large that it doesn't just burn up all of a sudden, it explodes. When that happens, the blast releases so much energy that a powerful shockwave spreads out. And since the explosion happens in the air, it leaves no impact crater. Back in the early 1900s, with limited technology and the remote location, scientists were left with a puzzle. Only much later did they eventually conclude it had been an airburst, where an object explodes high in the atmosphere, never striking the ground but releasing enough energy to devastate the area. Most likely, it was a giant asteroid about the size of a 25-story building. It could have been moving at around 33,500 miles per hour and exploding about 3 to 6 miles above Earth's surface. Another wild story happened back in the late 90s, but it wasn't Earth that was affected. A comet got stuck in orbit around Jupiter. One day, it got too close, and Jupiter's immense gravity broke it apart, turning it into a bunch of pieces. Some of them were as big as half a mile across. Scientists were curious because they didn't know what would happen when those pieces hit the planet. And in July 1994, the moment came. The comet's broken up pieces started crashing into Jupiter, one after the other. Over 6 days, 21 chunks of the comet smashed into the planet at insane speeds, like 37 miles per second. That's more than 130,000 miles per hour. The impacts were so powerful that they heated up Jupiter's atmosphere to a mind-boggling 53,000 degrees Fahrenheit, which is way hotter than the sun's surface. When each chunk hit, it sent massive plumes of material flying out of Jupiter, like when you throw a rock into a pond, but way bigger. Some of these plumes shot up almost 1,900 miles into the sky. Afterward, big dark scars appeared in Jupiter's atmosphere, and they stayed visible for months as the debris spread out across the planet. But this wasn't just a cool space event. Scientists actually learned a lot from it. Those dark impact marks helped scientists track the winds in Jupiter's stratosphere. The crashes even caused temporary changes in Jupiter's glowing auroras, showing that the planet's magnetic field was affected by particles from the explosions. Plus, the comet fragments didn't just make a mess, they also left behind new chemicals in Jupiter's atmosphere. Plus, some chemicals were also exhumed from the lower atmosphere. Some molecules like ammonia broke down over time, but others, like hydrogen cyanide and water, are still floating around Jupiter today. This helped scientists understand how different chemicals react and mix in Jupiter's atmosphere. Comet Shoemaker-Levy 9 was a wake-up call. It proved that massive space collisions still happen in our solar system. That's one big reason why NASA started looking into how we can track and prepare for any future impacts that might threaten Earth. Whether it's learning more about asteroids and comets, or about how giant impacts shape planets, the importance of such discoveries is undeniable.
It's been there for over 3 billion years, but now some of the Earth's oldest crust is falling apart. Today, our continents seem stuck in place, but over a long time, they've moved and shifted around a lot. It's all thanks to tectonic activity, which makes part of Earth's surface slowly slide around like pieces of a giant puzzle. Some of the most stable parts of these puzzle pieces are called cratons. Cratons are super old and strong sections of rock that form the roots of continents and keep them together. The North American craton is one of them. It makes up a big part of the United States, about half of Canada, and most of Greenland. Scientists have singled out about 35 of these big ancient cratons around the world. They've mostly stayed in the same place for hundreds of millions of years because of how strong they are. But in 2014, they discovered that cratons might not be as indestructible as they thought. Some cratons had lost parts of their strong roots because of certain geologic processes and became thinner. It looks like cratons could become less stable if they go through more tectonic changes. In 2024, scientists at China University of Geosciences analyzed an ancient landmass called the North China Craton, or NCC for short. They wanted to learn more about how some of Earth's oldest rock regions can break apart. This process of cratons disintegrating is called decratonization. The NCC is so interesting to study because it has 3 main parts: the Western Block, the Eastern Block, and the Trans-North China Orogen, a zone that lies between the 2 blocks. Scientists found that during the Mesozoic era, the Eastern Block lost its deep ancient roots because of the strong Earth movements called tectonomagmatic events. So scientists wanted to see exactly how the processes in the mantle and the movements of Earth's plates led to the breaking down of the NCC. They created 4D models showing how the NCC's shape changed over time, including its surface shape, how its layers stretched, and the way earthquake waves moved through it. They found that a section of the tectonic plate slid beneath the craton and then began to roll back. This rolling and stretching made the strong rock thin out and eventually lose stability. All this started around 200 million years ago, back during the Jurassic period, when dinosaurs were rocking the world. The North China Craton isn't the only place where this decratonization process can happen. Other cratons, like those in North America, South America, and China's Yangtze region, may have gone through similar changes. Scientists say this shows how the continents on Earth have slowly changed and evolved over billions of years. And it looks like, when it comes to geology, there's no place that is 100% safe from changes, but it's no cause for alarm. You don't notice this, but our planet never stops moving and is perfectly normal. But sometimes, this movement still brings dramatic changes. In 2017, scientists made an official announcement that Zealandia can be called a new continent. The continental shelves of this mysterious continent are lying at a depth of around 3,280 feet below sea level. The nearest oceanic crust dives even deeper, at 9,800 feet below that. Geologists have gone deep down to collect rocks from the ocean floor. They've found that, unlike the nearby oceanic crust, which is made up of fresh basaltic rocks, the crust around New Zealand is a mix of ancient granite, limestone, and sandstone. All this screams continental crust. Plus, scientists have discovered a narrow strip of oceanic crust that separates Australia from the hidden land of Zealandia. It means these two are separate continents. 85 million years ago, Zealandia decided to break free from the supercontinent Gondwana. Millions of years later, the mighty Pacific Plate, the heavyweight champion of tectonic plates, decided to take a dive beneath Zealandia's continental crust. And that's how the root of Zealandia, that connection to its continental crust, broke off and went into the depths below. And that's not all the tectonic news from this part of the world. 120 million years ago, Australia and Antarctica were a single piece of land. They went their separate ways, but Antarctica didn't leave empty-handed. Today, there's an oceanic plateau in the Indian Ocean. Long ago, it was connected to another lost continent, the Kerguelen microcontinent. Scientists believe that it made a land bridge between India and Antarctica. To find out what it was like, we can look at a tiny archipelago in the southern Indian Ocean. These islands are all that is left of the ancient landmass. They have a cold climate and feature glaciers because they're so close to Antarctica. But in the past, the weather here must have been temperate with plenty of rainfall. The animals and plants would have been similar to those that live in tropical regions today. Another lost and found continent isn't hiding in the ocean, but under Europe. It's called Greater Adria, and it collided with Europe and started to sink under it around 100 million years ago. Today it lies beneath Italy, Greece, and the Balkans. Its size and even shape match that of Greenland, the world's largest island. Greater Adria is no longer visible, but it left some clues. Part of it was embedded in the Alps. The other chunks are part of present-day Italy and Croatia, on the other side of the Adriatic Sea. Limestone rocks from the former continent started to change once they were under the European landmass. Great heat and pressure spread over tens of millions of years changed their structure. And that's when the limestone left the chat and the marble took its place. Greater Adria wasn't a solid piece of land like the big continent we see today, but more like a giant shallow shelf underwater. Over time, sand, mud, and other stuff settled on this shelf and slowly turned into rock. Greater Adria might have been a little like Zealandia or the Florida Keys, a chain of small islands sitting in a shallow sea. Above the water, there were probably lots of little islands and archipelagos, and beneath the waves, there were colorful coral reefs filled with marine life. If you lived back then and had a scuba tank, it would have been an amazing place to dive and explore. So, with all the things going on with the Cratons, who knows? We could see a new continent in the future. Plus, studying the Earth's crust even deeper can change history as we know it. Scientists in Copenhagen have made an amazing discovery about the real birthplace of Scandinavia, and it's not where we thought. After studying sand and rock from remote parts of Finland, they found out that Scandinavia's roots actually came from Greenland over 3.75 billion years ago. This means the area where Nordic countries are now is 250 million years older than the scientists had previously believed. And we now know, thanks to the tiny crystals called zircons found in Finnish river sands. When scientists looked closely at their chemical makeup, they realized the age of crystals matched the rocks found in Greenland, not Scandinavia. They used special techniques to analyze elements like uranium, lead, lutetium, and hafnium, and discovered that Scandinavia's rocky base most likely broke off from Greenland billions of years ago. A small seed of land probably started drifting across the Earth's surface over hundreds of millions of years. This piece eventually settled where Finland is today. Over time, new layers of rock formed around this seed and slowly turned into the Scandinavia we see on maps now. The same study could help us rethink how the continents on Earth first formed. The most accepted theory is that the continental crust began growing right when the planet was formed. But new studies show that the signs of continents only started growing a billion years later. The scientists explain that Earth's continents may have begun as tiny seeds of ancient crust in different places. These seeds grew over time, forming the landmasses we know today. These ancient seeds aren't just found in Scandinavia, but also in Australia, South Africa, and India. Scientists aren't sure if all these seeds came from the same place or if they grew separately in different parts of the world. So there's still a lot to learn, and scientists need to keep digging to figure out if all these ancient seeds are related to each other. A tsunami hitting major cities on or near the Mediterranean Sea and in the northeastern part of the Atlantic Ocean is not a matter of if, but when. It is scary and surreal to think that places like Cannes or Barcelona could suddenly get slammed by a huge wave. But the fact is, European coastlines are in active tectonic areas. Only about 10% of all tsunamis worldwide happen in the Mediterranean, and there have been at least 290 tsunamis in this area since 1600 before Common Era. Despite the relatively low number, this phenomenon has caused numerous devastating disasters throughout Europe's history. Back in 1755, an estimated 8.5 magnitude earthquake, with an epicenter southwest of Cape St. Vincent, triggered a tsunami that destroyed most of Lisbon, the capital of Portugal. About 40 minutes after the earthquake, this massive wave just slammed into the harbor in downtown, racing up the Tagus River. The phenomenon was so fast that several people on horseback had to gallop to higher ground to avoid getting carried away. And this was just the beginning of a nightmare, with 2 more terrifying waves hitting Lisbon right after. A disaster like this is similar to what we see in the Pacific Ocean several times a century, but in the Atlantic, it's very rare. This type of major tsunami is expected to happen every 3 to 5 centuries, but now it could happen tomorrow. Marseille in France, Chipion in Spain, and other cities are on the list of important locations that could be flooded soon, with a roughly 100% chance of being hit by a tsunami in the next 30 years. Statistics show that the wave will probably be more than 3 feet high. I know, it doesn't sound like much, especially since when we think about tsunamis, we imagine terrifyingly tall waves, like the one that hit Lituya Bay in Alaska. In that case, the wave was over 1,700 feet tall. But we must remember that even waves only 19 inches high can be dangerous to swimmers, because it's not the height of the tsunami that matters, but also the flow and movement of the water. Not to mention the flooding, which can damage beaches, harbors, and streets. If the coastline has a small harbor and the waterfront is exceptionally low, like Cannes, this natural disaster might be much more dangerous. Tsunamis around 6 feet high can lift cars off the ground, while smaller waves can create walls of water traveling at 40 miles per hour. Plus, there are these smaller events that might not wreck everything, but still can cost a ton of money. For example, large sandbars that move around on the ocean floor, like sand dunes shifting in deserts. They can mess up pipelines or deep-sea cables for internet and communications, and that ends up costing businesses and governments millions of dollars. That's why organizations like UNESCO are worried about the possibility of a dangerous tsunami hitting Europe soon. So they're doing everything they can to prevent apocalyptic scenarios, like what happened in 2004 when an earthquake off the coast of Sumatra, Indonesia, caused waves over 100 feet high in coastal communities, resulting in over 200,000 lives lost. And let's not forget about 2011, when an earthquake off the coast of Tohoku, Japan, triggered a tsunami that reached about 6 miles inland and caused a major nuclear accident at a power station along the coast. Over 16,000 people lost their lives in that tragedy, and the event resulted in billions of dollars in infrastructure damage. These disasters were huge wake-up calls, and we've come a long way since 2004. We're much safer today, largely because the tsunami warning system is highly effective at quickly detecting this dangerous situation. Unlike many other natural phenomena, a tsunami can be anticipated. We may only have a few minutes to act, but if we all know what to do, many lives can be saved. And in most parts of the world, sirens are commonly used to alert people to tsunamis. To sound the siren as early as possible, initial tsunami alerts usually rely only on seismic data. First, specialists receive information about an earthquake. Seismic waves travel about 100 times faster than tsunamis, so they have enough time to analyze the data and see if the earthquake might have generated a tsunami and whether they should issue an initial tsunami alert. At U.S. warning centers, for example, scientists typically issue initial alerts within 5 minutes of an earthquake. If a tsunami is suspected, these alerts may also include information about wave arrival times, recommended actions, and potential impacts. But sounding the alarm is not enough. To save lives, coastal communities also need to be trained to respond fast and in the best way possible. That's why UNESCO produced this program called Tsunami Ready, aiming to train people living in coastal areas at risk on how to act in case of a tsunami event by the year 2030. The idea is to help communities stay safe by teaching them how to protect their livelihoods and safeguard their homes. Being recognized as tsunami ready by UNESCO doesn't mean a community is tsunami-proof, of course. It's more like a recognition that they have adopted all possible measures to mitigate tsunami risks. So authorities are helping communities to prepare themselves by installing evacuation signs, establishing security procedures, and creating plans to warn tourists. Like Spain, which distributed tsunami warning signs along the entire coastline, as well as signs showing evacuation routes to higher ground. And Spain better be prepared. I mean, only 7 tsunamis have hit the country since the year 365, so it's difficult to predict the effects of such an event. But they could be devastating, considering that Spanish coastal areas are so economically important. There's also a danger zone in the Averroes Fault, beneath the Barents Sea. If an earthquake happens at this point, people will have only 21 minutes to escape a tsunami. UNESCO has also established 12 tsunami warning centers, which cover Europe as well. This initiative involves 5 centers located in the Mediterranean and Northeast Atlantic regions. These centers can save thousands of lives because they monitor ocean disturbances 24/7. Then, after analyzing the threat, they send out messages based on the event's potential to cause a tsunami. The intensity scale ranges from no effect to completely devastating. And by that, they understand that nearly all brick buildings could be demolished by waves, and even the most reinforced concrete structures could suffer heavy damage. Now, so far, we have mostly talked about tsunamis caused by earthquakes along converging tectonic plate boundaries. In fact, earthquakes have accounted for over 80% of tsunamis since 1900. But tsunamis can also result from landslides, volcanic eruptions, and even meteorite impacts. Experts are also worried that with the current changes in climate, we might see more of meteotsunamis popping up in the Mediterranean. These ones are triggered by freaky weather conditions and can mess with any coastline that's got a shallow seafloor. They might not be as huge or famous as the earthquakes ones, but they can still cause significant property damage and put people in danger. For instance, in 2006, a meteotsunami struck the harbor of Ciutadella on the Spanish island of Menorca. Yachts were tossed into each other and later stranded on the harbor floor as the water receded, resulting in tens of millions of euros in damage. Unfortunately, meteotsunamis in the Mediterranean tend to be stronger during summer, so if you're planning to spend your vacation in Europe, stay alert for any signs of dangerous waves. If you suddenly encounter a tsunami moving in your direction, remember this is the time to react. Move to higher ground as far inland as possible. Pay special attention to any emergency alerts and information, and follow the guidance of local authorities. Most importantly, do not wait around taking photos. Leave the area as soon as you notice any signs of this danger event, or if you hear an official tsunami warning. Hey, stay safe. So, in the end, will the sun be to blame for destroying our planet? Or how about a huge meteorite? Or some kind of disease? Probably not. It seems that life will disappear for a very unexpected reason. Humans, animals, insects, fish, and most microbes will be wiped off the face of the Earth because of oxygen, or more precisely, because of its absence. Recent research has shown that the number of freshwater reservoirs with very low or no oxygen levels in coastal areas is increasing worldwide. Over the past 65 years, 4 times more oxygen-deficient waters have appeared in the world's oceans. What does it all mean? It's likely that life on Earth will vanish much sooner than the sun's energies dries up all the oceans. The end is likely to come in a little more than 1 billion years. But this doesn't mean that the planet will disappear too. The period when Earth is filled with oxygen will make up just about 20 to 30% of the total lifespan of the planet. So we're just temporary guests here. Just think how long that is, 1 billion years. The first Homo sapiens appeared only about 300,000 years ago. That is, the entire history of humanity occupies less than 500,000 years. So relax. 1 billion years won't pass very fast. By that time, humans won't be on Earth anymore. We might master space travel and find a new planet in the vast depths of space. But why can we lose air? As the sun heats up, the planet gets warmer and warmer, and this heat breaks down carbon dioxide, the gas which is necessary for all plants to photosynthesize. Without carbon dioxide, they can't produce oxygen. With a drop in carbon dioxide levels, the methane content will increase, and this gas is quite harmful to us. Now, this all sounds logical, but this is a secondary reason for the lack of oxygen. The real problem is something else entirely. As the sun becomes brighter, it will begin to heat rocks on Earth, such as granite and basalt. These rocks will start to break down faster. When they collapse, they take carbon dioxide from the air, which warms our planet. If there's less carbon dioxide in the air, Earth should become colder. But there's a problem. The sun will shine more, and its heat will outweigh this cooling effect. So even if rocks take away carbon dioxide, the sun will blaze so much that Earth will still become extremely hot. Next, when the sun shines more intensely, it, along with other natural factors, contributes to the breakdown of granite and basalt. These rocks mix with carbon dioxide and water to make carbonates, which go deep into the Earth. This takes carbon dioxide out of the air, which means plants can't make as much oxygen because they need carbon dioxide to do that. Besides, volcanoes release gases, which also reduce the amount of oxygen in the air. So the sun, by destroying rocks, affects what happens inside Earth and controls how much oxygen there will be in the air. In about 1 billion years, the sun will become so bright that no rocks will be able to save Earth from its heat, and the escaping gases will halt photosynthesis and oxygen production. And then, our planet will return to the state it was in about 2.4 billion years ago, to the time when the Great Oxidation Event began. And this event was much more important than, say, the first Olympic Games or the appearance of humans on the planet. Billions of years ago, there was almost no oxygen on Earth. Instead, there was a soup of gases, such as nitrogen, ammonia, methane, carbon dioxide, and others. Yes, we have these gases in the atmosphere today, but there used to be a lot more of them in the past. It was difficult for any form of life to originate in such conditions. But after some struggle, it succeeded. At first, Earth was inhabited by the simplest bacteria, including cyanobacteria. They learned how to make oxygen using sunlight, water, and carbon dioxide. These bacteria worked for millions and billions of years and made so much oxygen that it began to accumulate in the air. This was what we now call the Great Oxidation Event. It was like a great celebration of life, because with oxygen, new living beings could appear. But by the way, cyanobacteria didn't learn photosynthesis because they were like, oh, let's make oxygen, it's so cool. No, oxygen was just a byproduct. Cyanobacteria wanted only one thing, to get as much energy as possible. And for this, they learned photosynthesis. It helped them store energy using sunlight. They used special pigments to absorb light, and the result of this process was the release of oxygen. This had been going on for hundreds of millions of years, and then, at some point, they made too much oxygen. This oxygen started to spoil other gases that had been there before. For example, it ate a lot of methane. Because of this, Earth cooled down a bit, and the Ice Age began. But that's another story. In short, in 1 billion years, we risk going back to that difficult time. But let's hope that we'll manage to move to another planet on our spaceships or come up with some other solution. And what'll happen to our home planet next? Will new life be able to originate there without so much oxygen? Well, it's possible, but it'll be much more difficult. This will require another source of energy besides the sun. It can be, for example, hydrothermal vents. And by the way, there are ecosystems on Earth that use this type of energy. You can find one of them in the Mobile Cave in Romania. Imagine a place where there's little oxygen. It's dark. The sun's rays don't reach there. Over millions of years of evolution, a unique and slightly creepy life has developed in this cave. It was first discovered in 1986, and scientists are still exploring this place. The entrance to the cave is just a small hole in the ground. A narrow tunnel goes deep underground. Inside the cave, the air is filled with hydrogen sulfide and carbon dioxide, and there's half as much oxygen there as on the surface. A human can't stay there without a special mask, but for local forms of life, this is home, and they feel great there. There are several dozen species living in the cave, and many of them aren't found anywhere else on Earth. Here you can see strange little monsters, white snails, white spiders, centipedes with long whiskers, transparent shrimp, and even unknown species of leeches. Since there's no light in the cave, all these creatures don't need eyes. They're blind, but they have long sensitive antennae and paws that allows them to navigate in the space. They also have no colored pigment, so all these bugs and spiders are either white or transparent. But if there's so little oxygen there, and nobody does photosynthesis, then how does all this life survive? It's all thanks to the unique bacteria autotrophs. They absorb carbon dioxide and produce nutrients. These bacteria are food for other organisms, and those, in turn, become food for larger creatures. So a whole food chain has been built in the cave, which provides all the inhabitants with food. Evolution has created a unique ecosystem that exists separately from the rest of the world. It's like a small universe that has developed according to its own rules. However, this universe is not expanding, because all living beings here can't live away from hydrothermal vents and autotrophs. Otherwise, where would they get their energy from? But let's imagine that the sun cools down, almost all the oxygen disappears, and the entire planet gets covered with hydrothermal vents. It's dark, and the air is filled with methane, CO2, and other substances, and somehow life begins. Even people appear at one point. What would they look like? Pale, thin, and blind creatures with very long arms that help them navigate in space. They have pets, large centipedes or cockroaches that move silently on the ground. People are also quiet because they don't have lungs filled with air to scream. There's silence in the world. People communicate through touch. No one travels. Everyone lives separately next to their hydrothermal source. The whole world has turned into a horror movie in 1 billion years.
Scientists discovered the largest water reservoir in the Oregon Cascades. It's hiding underground, holding more than twice the water volume of Lake Mead. Let me specify. It contains at least 19.4 cubic miles of water, which is almost 162 trillion bottles of water. If you drank 1 bottle a day, it would take you around 444 billion years to finish your stock. No wonder this underground aquifer discovery is so awesome. The Cascade Mountain Range, which contains the largest aquifer on Earth, stretches about 700 miles from Northern California to British Columbia. The high Cascades in Oregon have younger volcanic rocks, around 8 million years old. The Western Cascades are much older, 45 million years. They boast deep canyons and valleys. Scientists study the transition zone between these two areas to understand how water moved through volcanic rock and how volcanic processes had evolved over time. In the process, researchers measured rock temperatures at different depths. That's when the underground aquifer discovery happened. Normally, deeper rocks should be hotter because it's closer to the Earth's interior. But to everyone's surprise, in several areas, the temperature stayed the same even at greater depths. Well, this was a strong clue that water was flowing through the rock and cooling it down. In other words, the Cascades function like a natural water tower, storing and slowly releasing water into rivers and streams. These geological water findings are important for 2 main reasons. First, it's our potential water source for the future. Such a massive amount of water stored underground could be an important resource. So far, we don't know how long it will remain in its current state and how resilient it's going to be to changes. So, we need more research to properly manage its use. Secondly, it affects volcanic activity. When water seeps deep underground and reaches magma, it instantly turns into steam, creating extreme pressure that can trigger explosive volcanic eruptions. Understanding how much water is stored in volcanic rock could help predict future eruptions and the risks they pose. Now, even though this discovery is exciting, there are still many unanswered questions. Like, how does this water move through the volcanic rock? Or how much of it is actually usable as a water resource? Since this underground reservoir depends on rain and snow, a series of dry years could cause big problems for both water supply and volcanic stability. Researchers are now working to understand the full impact of the Cascades volcanic water reservoir and how to manage it responsibly. But let's look closely at the geological wonder that is the Cascade Range. Picture this: a massive mountain range stretching all the way from Northern California up to British Columbia, cutting right through the middle of Oregon. That's the mountain range we're talking about. In Oregon alone, it's about 260 miles long and up to 90 miles wide, covering 17,000 square miles. Whoa, that's bigger than each of the 9 smallest US states. The coolest thing is that the Oregon part of this mountain range is basically built by volcanoes, and apparently contains at least one volcanic rock water storage. The range itself exists because of something called the Cascadia subduction zone, where the Juan de Fuca tectonic plate, a chunk of Earth's crust under the Pacific Ocean, is slowly getting shoved beneath North America. As it sinks, the intense heat and pressure force water out of the oceanic rock. It lowers the melting point of the surrounding mantle and creates magma. That magma rises up and fuels the Cascade volcanoes. This is part of the Ring of Fire, the giant belt of volcanoes circling the Pacific. So, in a way, the Cascades are part of a much bigger volcanic system that's constantly shifting and changing. The Oregon Cascades are actually made up of 2 completely different zones: the Western Cascades and the High Cascades, and they look nothing alike. The Western Cascades are the older part. They formed around 45 million years ago. These mountains are rugged and deeply carved up by rivers. Some canyons are as deep as 3,700 feet. This part of the range used to be volcanically active, but over time, erosion has taken over, reshaping the land. The High Cascades, on the other hand, are much younger and way less eroded. Around 8 million years ago, the volcanic activity shifted, and new eruptions filled in old canyons, smoothing out the landscape. Eruptions kept piling up fresh lava, and rivers in this region didn't have as much time to create deep valleys like they did in the Western Cascades. That's why if you look at the 2 regions side by side, one looks jagged and carved up, while the other looks smoother and more built up. Some of Oregon's most famous volcanoes are located in the High Cascades. I'm talking about Mount Hood, Mount Jefferson, the Three Sisters, and Crater Lake, which actually formed when Mount Mazama erupted and collapsed in on itself. Unlike smaller volcanoes that pop up, erupt for a bit, and disappear over a few months or years, these giant volcanic centers have been active for thousands of years. And because they've been around for so long, they have way more complex magma systems. They produce everything from basalt, which is a runny, fast-moving lava, to andesite, dacite, and rhyolite. And rhyolite is the type of magma that leads to huge explosive eruptions. So, while some of these volcanoes might just ooze lava, others have the potential for devastating blasts. Another amazing thing about these long-lived volcanoes is that their underground magma chambers stay hot for a really long time. That's why the Cascades are one of the best places to tap into geothermal energy. There's a ton of heat just sitting beneath the surface, waiting to be used. Oh, and don't forget about the Cascades volcanic water reservoir. Who knows how we will use it in the future? Now, we already know that the Cascades are part of the magnificent Ring of Fire, Earth's most explosive zone. Imagine a massive horseshoe-shaped belt wrapping around the Pacific Ocean, stretching for about 25,000 miles. It's one of the most geologically active areas on the planet. This is where Earth's tectonic plates are constantly shifting, colliding, and grinding against each other, creating some of the world's most powerful earthquakes, volcanic eruptions, and deep ocean trenches. The Ring of Fire follows the meeting points of multiple tectonic plates, and they all surround the giant Pacific Plate. These plates aren't just sitting still, they're always on the move, pushing against or sliding beneath each other at their boundaries, known as fault lines. When this happens, you get everything from deep-sea trenches to towering volcanoes and violent earthquakes. One of the most extreme examples of this activity is the Mariana Trench, located east of Guam. At 7 miles deep, it's the deepest ocean trench on Earth. It was formed by a process called subduction, where one tectonic plate is forced beneath another, sinking deep into the Earth's mantle. The Mariana Trench is one of the most mysterious places on Earth. It's insanely deep, with crushing pressure and total darkness. So for a long time, people thought nothing could live down there. But it turned out that life existed even at the very bottom. In 2005, scientists found a tiny single-celled organism in the Challenger Deep, the deepest part of the Mariana Trench. They also came across colorful rocky formations and weird sea cucumbers. The Mariana Trench also has hydrothermal vents, which are basically underwater hot springs. Even though the water there is super hot and acidic, strange creatures and microscopic life forms still manage to survive there. The Ring of Fire is also responsible for 90% of the world's earthquakes. Some of the most powerful quakes in history have happened here, including the 1960 Valdivia earthquake in Chile, the strongest ever recorded, which hit a mind-boggling 9.5 on the Richter scale. But it's not just about earthquakes. The Ring of Fire is also home to about 75% of the planet's volcanoes. Some of the most famous eruptions in history have come from this region, like the infamous Mount Tambora in Indonesia. In short, the Ring of Fire is one of the most dangerous places on Earth, but it's also incredibly fascinating. Who knows what else scientists might discover in that region, like they discovered the largest water reservoir in the Cascades.
Our planet's biggest and meanest supervolcanoes are waking up. When they erupt, you'll surely notice it, even if you live thousands of miles away from the epicenter. Scientists are worried we might not have enough time to prepare and deal with the consequences of a supereruption. There's some volcanic activity close to the Italian city of Naples. And no, it has nothing to do with the famous Mount Vesuvius, but with another volcano. This one is harder to see as it doesn't have a tall peak like Vesuvius. But don't let this bad guy trick you. It could be way more dangerous than its giant neighbor. It does have a huge crater that's about 8 miles wide. This volcano is called Campi Flegrei, and it's actually one of the largest volcanoes in Europe, sitting under the town of Pasquale. So, Campi Flegrei erupted 39,000 years ago with a bang so massive it spread ash across the whole Mediterranean region. It also caused the temperature to drop by over 16 degrees Fahrenheit across Eastern Europe. It was the biggest volcanic eruption in Europe in 200,000 years. Since then, Campi Flegrei has had smaller eruptions, and the last one happened in 1538. Now the area is full of small craters, hot springs, and bubbling pools, and they're all proof that this volcano is still very much alive and brewing something. Since the early 2000s, the ground in the giant crater and the town nearby have been slowly rising by about 1 to 1.5 inches every year. There were at least 150 earthquakes that shook this supervolcano lately. In May 2024, there was a 4.4 magnitude in the area, the biggest in the last 40 years. Residents had to leave their homes and camp outside, fearing there would be more earthquakes. No one knows how Campi Flegrei is going to behave in the following months or years, but the authorities are organizing evacuation exercises to prepare the population just in case. The Italian volcano looks like an innocent kitten compared to the real giants like Yellowstone. For a volcano to deserve the title of a super one, it must be able to produce catastrophic-scale eruptions and eject huge amounts of magma, ash, and volcanic gases. The Yellowstone giant meets these criteria. Even though it moves from time to time, the Yellowstone supervolcano hasn't erupted for 640,000 years. But when it does wake up, it might erupt with incredible power, about the same amount as 10 huge nuclear power stations can produce. Under the ground, beneath Yellowstone, there's a super hot area full of molten rock called magma. As more magma moves into a big space called a magma chamber, the ground above starts to swell or rise. When the magma cools down, the ground falls. Between 2004 and 2009, the ground at Yellowstone rose by almost 10 inches, but then it started to slowly go back down in 2010. Scientists aren't sure if it's going to erupt anytime soon. There's also another big volcano called Long Valley in California that has been active since 1980 and it can be a really big threat. Scientists studying this supervolcano found out that before its biggest eruption, 760,000 years ago, the buildup may have taken less than a year. Now, that's bad news, because a supervolcano eruption can have a huge effect on the world, like the eruption of the Toba volcano in Sumatra around 74,000 years ago. It became the biggest volcanic eruption the Earth had seen in 28 million years. It covered parts of Indonesia, India, and the Indian Ocean with a thick layer of volcanic debris, almost like a 6-inch blanket. The amount of rock it spewed out was like stacking nearly 3 million Empire State Buildings. The giant crater it left behind can still be seen from space. All the ash and gases shot up into the air and blocked some of the sunlight. It caused a volcanic winter that lasted about 6 to 10 years. Some scientists think this eruption might have even affected early humans. Around the time Toba erupted, the human population took a sharp dip, and there were far fewer people. Some say this is why all modern humans come from a small group of survivors. According to the Toba catastrophe theory, most early humans in Europe and Asia didn't survive the cold and harsh climate after the eruption, but a lucky group lived through all that in Africa. Not all scientists agree with this idea, and some archaeological and climate records show a different story. Another volcano that changed the world in a big way was Mount Tambora in 1815. The next year went down in history as the year without a summer. It was cold and rainy, and there was snow and frost even in the middle of summer, especially in Europe and North America. This happened because the volcano sent out a lot of sulfur dioxide into the sky, which spread all over the world and made the planet colder. When Tambora erupted, it caused huge tsunamis that smashed homes and took the lives of around 10,000 people. Afterward, about 80,000 more people passed away because of the consequences the eruption had caused in the world. The cold weather ruined crops, so food became really expensive. And because horses were the main way people traveled, the cost of oats that they ate went way up too. Some people even think this led to the invention of the bicycle in 1817 as a new way to get around. The eruption made the Earth colder for about 3 years. Now, even though the Tambora eruption was so powerful, Krakatoa, another volcano in Indonesia, stole the show when it erupted in 1883. It was just easier to spread information about it through telegrams and photos. Its final blast was the loudest recorded sound in history, and people could hear it on 10% of the entire Earth's surface. The eruption started a tsunami, with waves about half as tall as the Statue of Liberty. Now, if we only had 12 months to prepare for a supervolcano eruption, it would be really hard to store enough food and get ready. But don't panic just yet. Supervolcano eruptions are very rare, and the last one happened 26,500 years ago in New Zealand. Scientists think that a super eruption happens once every 100,000 years on average. But the sad part here is that the Earth doesn't follow a perfect timeline. There could be clusters of super eruptions with shorter gaps between them and then longer quiet periods. Since there have already been 2 super eruptions in the last 100,000 years, there's always a chance one could happen again sooner than we expect. Plus, although there are places like Yellowstone and Long Valley where we expect volcanoes to erupt, there are less obvious possible hotspots. In Chile, there's a volcano called Laguna del Maule that has erupted in the past and left behind a huge crater. Over the last 20 years, the ground there has been swelling really fast, rising up to almost 1 foot a year. Some people are worried that this could be a sign of a big eruption coming. But scientists say there's not enough magma yet to cause a super eruption. In Bolivia, the Juturancu volcano is also acting up. It's part of a group of volcanoes that have caused super eruptions in the past. Since the 1960s, the ground around Juturancu has been lifting, but the last eruption was 250,000 years ago. Even though the magma might be rising, it's not enough to worry about just yet. The chances of a super eruption happening during our lifetime are 1 in 1,400, which is pretty low, so you don't need to worry too much. But just like someone wins the lottery every week with very small chances, a super eruption could happen sometime in the future, and when it does, we'll need to be prepared.
On September 16th of 2023, without warning, the Earth began to hum. A low, strange vibration reverberated through the crust. This set off seismic alarms all across the globe. For 9 days straight, the planet was pulsing with this horrifying rhythm, and scientists had no idea what was going on. Meanwhile, the total disaster was happening in Greenland. It wasn't an earthquake. They knew that much. They could tell it by the rhythm. Since we all live on giant tectonic plates, they constantly move and slide on magma like icebergs on water. Sometimes as they move, they can rub against each other or collide or break. In any case, all this causes an incredible release of energy that sends shock waves through the ground. That's when we feel the ground literally shaking, and it's what we call an earthquake. These vibrations we feel are called seismic waves. Seismometers pick them up as pings or rumbles. In a typical earthquake, they create a bunch of different frequencies. It's a crazy chaotic mix of low and high frequencies, like smashing every piano key. What was weird about the Greenland event is that the signals weren't like that at all. It was a steady, single-frequency vibration, as if some ancient machine was stirring beneath the Earth. It's like one piano key being struck over and over, creating a doom-like, repetitive sound. Turns out, what they were hearing wasn't the noise of tectonic plates going wild. It was a phenomenon seismologists had never seen before. The days passed, and the mysterious noise just kept going. The vibrations repeated every 90 seconds, echoing around the world. The hunt for answers was growing more desperate. Seismologists had no idea what they were dealing with. They had to gather a huge international team of 68 people from 15 countries. All these scientists were gathering seismic data, satellite images, and doing some advanced math for several days, until they finally realized who the culprit was. Water. It all happened in a remote, desolate region of East Greenland. This place is full of fjords, narrow inlets of the sea between high cliffs, kinda like deep water-filled valleys surrounded by towering rocky sides. In this area, surrounded by jagged peaks and icy waters, the air was still. The landscape seemingly frozen in time. Nothing here changed much for years, until one day. A colossal landslide has unfolded in the Dixon Fjord. One of those steep mountainsides towering over the fjord at almost 4,000 feet high collapsed in a massive landslide. Picture a huge chunk of this mountain crumbling and crashing down into the fjord below. This sent a deluge of rock and ice crashing into the water. The impact was just apocalyptic, 882 million cubic feet of debris. That's enough ice and rock to fill 10,000 Olympic-sized swimming pools, or 10 Great Pyramids of Giza. And all this nightmare hurled into the water with such force that it kick-started a tsunami about 360 feet high, taller than the Statue of Liberty, into the air. What's crazy is that this incredibly powerful wave was trapped in the fjord by narrow cliffs, unable to escape. It's like water sloshing in a closed bathtub. For 9 days, the mega tsunami continued to churn through it. That's why we heard this endless hum. It was a rhythmic back and forth of the water slamming against the walls. The shock waves were rippling deep into Earth's crust, vibrations so strong that they were picked up by seismometers around the globe. This was a phenomenon so rare, so unprecedented, that it left scientists stunned. It turned out to be a perfect storm of elements. A glacier, weakened by years of warming, could no longer bear the weight of the mountain above. This collapse was inevitable, and the chaos literally shook the Earth to its core. And people often hang out in this area with cruise ships passing by. We're lucky that no lives were lost in the disaster. It was a close call though. A tourist ship stranded in the area just 2 days before narrowly escaped the tsunami's reach by pure luck. But it doesn't mean there were no losses. The waves destroyed a nearby Inuit site, which was there untouched for over 200 years. They also swept away the huts at a research station that were about 43 miles away. The vibrations traveled from Greenland to the South Pole in less than an hour. That just shows how dangerous events like this can be. And this isn't the only place where such catastrophes are happening. In the beautiful California community of Rancho Palos Verdes, the ground is shifting so quickly that it's tearing homes apart. The land there has always been kinda unstable. It has some unique geology. It's built on soft, clay-rich soil and sits on a geological fault line, which makes it prone to landslides. This means that this land is prone to slow, natural shifting over many years, even when no crazy weather is happening. It's been like this for decades, but usually it's slow and pretty manageable, like about a foot a year. Imagine a tree that you played with as a kid moving 20 feet to the left as you grow up. For decades, residents adapted. They built their homes on adjustable beams. This helped the houses to move with the land, and that strategy worked well until now. Recently, things have been getting much worse in the community. Now, the land is moving by a foot in a single week. That would be like if the same tree moved almost 960 feet since you were a child. The past 2 years have also caused some heavy rains, and the weather has been getting worse. This increased water content in the soil. The land became heavier and more prone to rapid movement. Now, this once idyllic seaside escape turned into a disaster zone. Cracks have appeared in closets, gardens, and roads, growing larger with each passing day. Streets that were once smooth are now buckled and twisted, with roads turning into a crazy theme park. Houses that once stood firm are being ripped from their foundations, some of them split in half. One of the houses had its front door 8 feet off the ground. Entire neighborhoods have been plunged into chaos. Utility companies had to switch off gas and electricity indefinitely to prevent potential disasters. The hardest hit is the coastal neighborhood of Portuguese Bend, where residents are living on the edge, literally. It always had amazing ocean views and cool sea breezes, with horses and peacocks still wandering the tree-lined streets. But now, it's like an earthquake hit. Only this time, the earth isn't stopping. For many, this place feels like paradise, if only the land would stop shifting beneath their feet. So the locals don't give up. Some of them had to leave, but many are determined to stay and fight, despite the destruction. But they still have to pour in hundreds of thousands of dollars to save their properties. People have installed generators to keep the lights on and set up sewer systems and pumps to drain the groundwater causing the landslides. Some say that the only way for these neighborhoods to survive might be to go completely off-grid, installing power walls to store energy and stuff like that. People are trying their best to run the sewer system off generators. They hope that they could get rid of this water in the soil that's causing these hellish landslides in the first place. They're determined to fight, but they will need help and support from the government to fight this disaster. Landslides are actually more common across the US than many might think. And new maps and data show that tons of people in the country might be in danger. Scientists managed to create the first very detailed, very cool map that shows where these landslides might happen, county by county. It's based on a lot of data and the history of 1 million previous landslides. They say that nearly 40% of the United States is at risk of experiencing landslide activity, which could lead to some insane catastrophes in certain areas. Luckily, now both residents and engineers can keep this in mind. But all this shows how vulnerable we are to natural disasters and how we should always stay alerted. An asteroid broke off the moon and now it's super close to Earth. Does it pose a danger to us? Kama'oalewa, also known as 2016 HO3, spins super quickly as it orbits near our planet. Let's call it HO3 for short. Astronomers found it on April 27, 2016. Compared to other asteroids, it's tiny. On Earth, though, it would be the size of a small building, or about half the size of the London Eye Ferris wheel. They discovered it in Hawaii, and its name roughly translates to a fragment of something that seems to wobble. After some study, they realized that this asteroid might be a chunk of the moon that got blasted into space. There's a part of the moon called Giordano Bruno crater, named after an Italian philosopher, that guy who had to pay quite the price for his ideas. If you look at it from space, Giordano Bruno stands out because it's surrounded by some rays of material. They're super huge, stretching over 93 miles and are still bright. This means that an enormous boom once happened there. There's an interesting story about this. In 1178, 5 monks were traveling in Canterbury, England. Suddenly, they saw something strange happening on the moon. They said it looked like the moon was splitting, with flames and sparks. Then there was a darkening that spread all across the lunar surface. In the 20th century, scientists found these records and thought that these monks saw the formation of the Giordano Bruno crater. But later it turned out that the crater is about 4 million years old. And thank the stars, because such a massive impact, if it really happened in the 12th century, would have gone crazy on our planet. It would have caused a huge meteor storm on Earth. In any case, our HO3 is most likely a piece of the moon that broke off during that impact 4 million years ago. Luckily, there's no need to panic about it. When astronomers spotted this sudden moon piece, they quickly tracked its orbit. Turns out, it won't collide with us anytime soon. It's going to be our quasi-satellite for at least 300 more years, meaning it'll follow a path around the Sun that keeps it close to Earth without colliding. Its orbit is wild though. It seems to be constantly looping around our planet in some pretty unique loops, moving closer and going away, up and down. And then somewhere in the 24th century, it will go even more crazy, switching to a horseshoe orbit, slowly going away from us. Could HO3 collide with us someday? Maybe, but that would happen over millions of years, when it would leave its current orbit and collide with Earth, Venus, or even the Sun itself. Or maybe entirely ejected from the solar system. Even though it's one of the closest asteroids ever discovered, it's also one of the smallest and most stable ones. This discovery also opens up some exciting ideas about life in the universe. We see that rocks can travel between celestial bodies. There is a theory that life could have been spread all across the universe by traveling on these rocks like on some space Ubers, or at least the building blocks of life like carbon. Maybe life even hitchhiked to our planet on rocks from Mars. HO3 probably doesn't carry any life, but the fact that it can travel for millions of years carrying stuff on it and feeling fine supports this theory. Astronomers want to send something to investigate HO3. Back in 2017, a group of students gave an idea of using a spacecraft for it. The China National Space Administration wants to send a robotic probe to HO3 somewhere in 2025. The robot should fly there, collect samples, and bring them back to Earth for study. Unfortunately, you can't see this asteroid in the sky with the naked eye. Its size is about 130 to 330 feet in diameter, so it would be too tiny and dim to see without a super powerful telescope. But there is an asteroid that you'll be able to see, and it will be insane. In 2029, a large asteroid will pass so close to Earth that it will be visible to the naked eye. Make sure not to miss it, because this is a once-in-a-thousand-year event. The asteroid is known as 2004 MN4, or Apophis for short. It's much bigger than HO3, about 1,210 feet wide. This will be the closest asteroid passage ever. This one actually caused some panic back in December 2004, all because there was a 2.7% chance that it could hit Earth in 2029. People were horrified. Even the name, Apophis, is inspired by an evil serpent from ancient Egyptian mythology. A huge monster that fought Ra and always tried to swallow the sun and destroy the planet. Luckily, when scientists got more data, they realized that it would pass pretty close to us in 2029, and we'd be able to see it in the sky. But then, it will just fly away like a chill asteroid. There was another worry though. That during its close pass, Apophis might travel through something called a gravitational keyhole. Basically, that it could travel through a specific narrow region of space which would accidentally alter its orbit. And then it would make an epic comeback in 2036. like the planet from the movie Melancholia. However, after some calculations, scientists ruled out this possibility as well. Apophis will still come quite close to us in 2036, but it will be about as far away as Venus is when it overtakes Earth. And then, Apophis and Earth will just go their own separate ways. On average, an asteroid the size of Apophis is only expected to hit Earth once every 80,000 years. And if it did hit us, it would completely destroy a huge area, causing earthquakes and tsunamis all around the world. But it wouldn't cause an apocalypse or anything like that. You'd only be able to see Apophis from Europe, Africa, and Western Asia. So if you want to see it, you might need to travel. The asteroid will look like a fast-moving star in the night sky, shining bright enough to be seen without any special equipment. It would be easy to spot at night, though city lights might make it harder to see. Now, can you imagine that these are not the only guys hanging nearby? Both HO3 and Apophis are part of the so-called Apollo orbit asteroids. These are the asteroids with orbits going around Earth, an entire group of dangerous fellas. Since they cross Earth's orbit, they have the potential to come close to or even collide with our planet. The first asteroid of this group to be discovered was 1862 Apollo, named after the Greek deity of the sun. It was first discovered in 1932, and the group was named after it. This one was even bigger, almost a mile in size. In fact, it's so huge that it even has its own tiny moon. Apollo crosses orbits of not just Earth, but also Venus and Mars. Fun fact, even though it was the first one of its kind, telescopes accidentally lost it out of view for over 40 years. So scientists went, oh well, let's just keep the count of things we can see. When Apollo was rediscovered in 1973, it wasn't the first asteroid on the list and got a big number in its name. Apollo will fly near us during the next hundreds of years. In 2075, it will be somewhere around Venus, but it should fly by as well. In any case, there's no need to worry, because astronomers are keeping a close track on these guys. If we were in any immediate danger, we'd have known. In order for an asteroid to totally destroy life on our planet, it should be bigger than 6 miles in diameter, like the one that helped to wipe out the dinosaurs 66 million years ago. But these guys are so crazy rare, we'd probably live on other planets by the time they arrive on Earth. In May 2024, stunning auroras adorning the night sky demonstrated all the power that solar storms emit as radiation. But sometimes, our sun does things that are far more destructive. I'm talking about solar particle events. During these events, blasts of protons coming directly from the surface of the sun can shoot out like giant cosmic searchlights. According to records, an extreme particle event hits Earth every 1,000 years or so. It often causes bad damage to the ozone layer and increases levels of ultraviolet radiation closer to the surface of our planet. Luckily, Earth's magnetic field acts as a powerful protective cocoon for our planet, fending off electrically charged radiation from the sun. In its normal state, this field functions like a ginormous bar magnet, with field lines rising from one pole, looping around the planet, and dropping at the other pole. This pattern is sometimes called an inverted grapefruit. This vertical orientation of the magnetic field at the poles allows some ionizing cosmic radiation to get through the field as far down as the upper atmosphere. There, it interacts with gas molecules and produces the glow we know as auroras. But over time, Earth's protective bubble changes. In the past century, the North Magnetic Pole moved across northern Canada at a speed of about 25 miles per year. Plus, it weakened by more than 6%. Even more shockingly, according to geological records, there have been periods of time as long as centuries and millennia when our planet's magnetic field was super weak or entirely absent. But we'll talk about those tragic times later. It's easy to imagine what our planet would look like without its protective bubble if you look at Mars. The red planet lost its global magnetic field long ago. And once this field disappeared, most of Mars's atmosphere vanished too. In May 2024, a strong solar particle event hit the planet. It disrupted the operation of the Mars Odyssey spacecraft and made radiation levels at the surface of the red planet rise around 30 times higher than what a person receives during a chest X-ray. The Sun's outer atmosphere constantly emits a changing stream of electrons and protons, the solar wind. At the same time, the surface of the star also produces bursts of energy, mostly protons, during solar particle events. These bursts of energy have a connection to solar flares, extremely powerful bursts of electromagnetic radiation that can last from minutes to hours. Protons are way heavier than electrons and carry more energy. That's why they can reach lower levels of Earth's atmosphere, exciting gas molecules in the air. These excited molecules emit X-rays invisible to the unaided eye. Dozens and hundreds of relatively weak solar particle events happen during every solar cycle. Now, let's speak about solar cycles for a minute. You see, from a distance, the Sun seems to be calm and steady, but if you zoom in, you'll see that its surface is constantly seething and churning. It keeps transforming from a uniform ocean of fire to a chaos of warped plasma and back again in a repeating cycle. Every 11 years or so, the magnetic field of our star gets tangled up. Imagine a ball of tightly wound rubber bands. That's what it looks like at such moments. And then, at one point, it snaps and flips completely, turning the North Pole into the South Pole, and vice versa. Right before this event, the Sun steps up its activity. It starts to spit out giant blobs of fiery plasma, emit powerful streams of radiation, and grow planet-sized spots. This period has the name of solar maximum. It's a rather dangerous time for Earth, since it gets regularly hit by solar storms. Such storms have the potential to disrupt communications and damage power infrastructure. Even worse, solar storms can harm astronauts working in space and even make satellites crash into the planet. As the cycle ends, it fades back to the solar minimum, and then a new cycle begins. Anyway, back to our solar particle events. Researchers have found traces of extremely strong solar events happening throughout the history of Earth. And some of them were thousands of times stronger than anything our modern instruments have ever recorded. Such extreme solar particle events happen approximately every few millennia. The most recent one occurred around 993 CE. Beyond the immediate effect they have, solar particle events can kickstart a chain of chemical reactions in the upper atmosphere. And these processes often lead to depletion of ozone, which isn't a good thing. Ozone absorbs harmful solar UV radiation, which can damage not only our eyesight, but also the DNA of living beings. Plus, changing the amounts of ozone in the atmosphere can impact the climate. In a recent study, researchers used large computer models to examine how extreme solar particle events affect Earth. They found out that if a solar proton event arrives during a period of time when our planet's magnetic field is very weak, then ozone damage can last for 6 years, and the level of UV radiation might increase by 25%, boosting solar-induced DNA damage by around 50%. And apparently, this dramatic combination of a weak magnetic field and extreme solar proton events happens quite often. And some researchers believe that it may even explain a few mysterious occurrences in the past of our planet. For example, the most recent period of weak magnetic field started 42,000 years ago and lasted for around 1,000 years. This period included a temporary switch in the North and South poles. Several major evolutionary events happened during that time. For example, the last Neanderthals disappeared in Europe, along with the extinction of marsupial megafauna in Australia. Yeah, sadly, we won't see any giant wombats and giant kangaroos anymore. One more, even bigger evolutionary event might also be linked to Earth's geomagnetic field. Multicellular animals appeared at the end of the Ediacaran period, which started around 635 million years ago. and it occurred after a 26 million year period of extremely weak or even absent magnetic field. The rapid evolution of different groups of animals in the Cambrian explosion, about 539 million years ago, might have also been related to high UV levels and geomagnetism. The simultaneous evolution of hard body shells and eyes in multiple unrelated groups could have been necessary to detect and avoid harmful incoming UV rays. A complete reversal of Earth's geomagnetic poles might have a serious impact on the climate of our planet. Luckily, such flips don't happen overnight. The entire process stretches over thousands of years. Plus, even though the magnetic pole weakens during a pole reversal, it doesn't disappear completely. That's why the magnetosphere continues protecting the planet from cosmic rays and charged solar particles, even though there might be some amount of particulate radiation that will make it to Earth's surface. Our planet's magnetic fields are generated by moving electric charges. If some material allows these charges to easily move in it, it's called a conductor. Metal is a great conductor, and we often use it to transfer electric currents from one place to another. In this case, the electric current's negative charge, called electrons, move through the metal. The current is what generates a magnetic field. Earth's outer core is made of liquid iron and nickel. In other words, there are layers and layers of conducting material inside our planet. Currents of charges are constantly moving throughout the core, and the liquid metal is also moving and circulating there, generating the magnetic field. This magnetic field, in turn, produces something resembling a bubble around the planet. It's called the magnetosphere, and it's located above the uppermost part of the atmosphere. This layer shields and deflects high-energy cosmic ray radiation, which otherwise would be extremely hazardous to people and other forms of life on Earth. The magnetosphere also interacts with the ionosphere, the layer of our planet's atmosphere containing loads of ions and free electrons and capable of reflecting radio waves. The interaction between these two layers and magnetized solar winds is what scientists call space weather. The solar wind is normally mild, and there's no space weather whatsoever.
Well, we've been miscalling Uranus all this time. Actually, astronomers say we should be pronouncing it like Uranus, not Uranus. I can't say a different stress changes much, though. However, things could have been different. Initially, Uranus was supposed to have the majestic king-like name of George, because astronomers wanted to name it after King George III. In the end, they changed their minds, and now, well, it's the punchline of every joke. If you take the total cost of launching a mission and divide it by the weight of the cargo, you'll see some pretty mind-blowing figures. According to specialists, back in 2016, it used to cost $10,000 to send just 1 pound of cargo into space. But now, prices have gone through the roof. Cygnus spacecraft's cargo costs over $43,000 per pound, while SpaceX's new carriers come in at around $27,000 per pound. Remember how hard it is to pay $5 for water at airports? Now, a bottle of water in space would cost somewhere between $9,000 and $43,000, and that's only to have it delivered in space. Now, as for water in space, well, it used to be considered a super rare thing. But in reality, there's water ice all over our solar system, so you don't have to buy those overpriced $43K water bottles. It's hanging out there in comets, asteroids, and even in hard-to-see craters on Mercury and the Moon. We're not sure if there's enough water in these places to support colonies of people, though. Mars also has ice at its poles, hiding under the surface dust and frost. Even smaller celestial bodies, like Saturn's moon Enceladus and dwarf planet Ceres, have ice. NASA scientists think there might be a chance of finding life on Jupiter's moon Europa. There might be liquid water beneath its icy shell. Europa, even though it's a lot smaller than Earth, might have an ocean deep enough to hold twice as much water as all the oceans on our planet combined. In 2009, scientists exploring a massive cloud of dust and gas in the center of our galaxy stumbled upon a fascinating surprise. They found ethyl formate within the cloud. This chemical is responsible for the delightful flavor of raspberries and has a rum-like scent. Furthermore, another nearby region is brimming with ethyl alcohol, the same type found in many beverages. In fact, there is enough alcohol in this region to provide every person on Earth with 300,000 pints of beer every day for the next billion years. Now, believe it or not, we do have a black hole on Earth. The thing is, creating an in-lab black hole was a sort of indispensable thing to do. Studying black holes in real space remains a distant dream, so it was only possible to create one to experiment with in a lab. A group of scientists in the Netherlands wanted to explore the mysterious Hawking radiation theory proposed by the iconic Stephen Hawking. Using atoms to mimic an event horizon, they orchestrated electrons, causing a surge in temperature that resembled flat spacetime. As particles moved through quantum fluctuations, a ring of infrared radiation appeared around the lab-grown black hole, mirroring Hawking's idea. So, if you totally understood what I just said, could you please explain it to me? Now, it may sound insane, but you can totally be allergic to the moon. Long story short, it was the final Apollo mission, and they brought back more rock samples than ever before. Plus, they had the first and only pro-scientist on the moon, Jack Schmitt. He was a geologist, and his rock samples helped scientists learn more about the moon's magnetic field and volcanic history. During the expeditions, it became evident that Jack Schmitt was allergic to moon dust. The gritty, sticky powder clung to his suit and his skin, causing irritation in his sinuses, nose, eyes, and throat for a couple of hours after he took his helmet off. Meanwhile, neutron stars are extremely dense, being basically just a bunch of neutrons squished into a super small space. If you had just a teaspoonful of this stuff, it would weigh more than the entire human population combined. And to match the density of a neutron star, we'd all have to squeeze into the space the size of a sugar cube. No thanks. When it comes to outer space, we tend to think that Earth and the Moon are pretty close together. But in reality, you can actually squeeze all the other planets of our solar system between Earth and the Moon. The average distance between them is about 240,000 miles. If you added up the diameters of the 7 planets, you'd still have some room to spare, about 5,000 miles. In 2011, scientists made a groundbreaking discovery of a massive reservoir of water in space. This water, equivalent to 140 trillion times all the water in Earth's oceans, could provide each person on our planet with a planet's worth of water 20,000 times over. This reservoir was located near a massive black hole drawing in matter and emitting energy, known as a quasar. The water was formed by energy waves colliding hydrogen and oxygen atoms together, and it was found around 12 billion light-years away. So, when the Curiosity Mars rover snapped its very first sunset picture in 2015, scientists were practically doing backflips from excitement. Turns out, sunsets on the red planet are anything but red. They're actually a stunning shade of blue. According to NASA, the reason behind this phenomenon is that the dust in Mars' atmosphere is like a magical filter that lets blue light shine through while blocking out those warm tones like yellow, orange, and red. Well, Venus is a slow spinner compared to Earth. It takes this planet 243 days to make a full rotation, and it spins in the opposite direction. But even though Venus takes longer to spin around, it zooms around the Sun in just 225 days because it's located so close. So, believe it or not, a year on Venus is actually shorter than its day. So, you might think that the night sky should be full of stars with no dark spaces at all. This idea is known as Olbers' paradox, named after German astronomer Heinrich Wilhelm Olbers. He thought that if the universe was infinite, unchanging, and timeless, then we should see stars everywhere we look. But it turns out that the universe is not infinite, unchanging, or timeless. Edwin Hubble discovered that the universe is actually expanding, and the leftover radiation from the Big Bang tells us that the universe is about 13.8 billion years old. Think of all the birthday candles. Ooh! So, the reason we don't see stars in every direction is because some stars are just too far away, or they haven't been around long enough for their light to travel all the way to us. During the Apollo 16 lunar mission, Ken Mattingly, the command module pilot, had a bit of a scare when he realized his wedding ring was missing. The whole crew frantically searched the spacecraft for it, but no luck. Finally, on day 9, while Mattingly was on a spacewalk, the ring was spotted floating out the hatch door. Charles Duke Jr. tried to grab it but missed. Luckily, it bounced off Mattingly's helmet into Duke's hands. It's cool they found the ring, but there are many other things people left up there. There's even a toothbrush floating around somewhere. Mercury is already the tiniest planet in our solar system, not counting Pluto, of course, and the second densest after Earth. And believe it or not, it's actually shrinking and getting denser. For a long time, scientists thought Earth was the only planet with tectonic activity. But that all changed when the Messenger spacecraft flew by Mercury, giving us a detailed scan of the whole planet. In 2016, Messenger discovered these cool cliff-like formations called fault scarps. Since they're still relatively small, scientists think they're pretty new, suggesting that Mercury is still contracting 4.5 billion years after the solar system began. And around 10 years ago, Australian astronaut Luca Parmitano went through a near-drowning experience during his spacewalk due to a water leak that went unaddressed. Nobody knew how it happened and why Luca ended up having water in his helmet. NASA was investigating the issue for months, but they were unable to determine the exact cause of the water entering Luca's helmet. Hey, can you lift a truck with your hands? No? Shocker. But let me introduce you to nature's original strongman, the ocean, which casually tossed 700-ton boulders around like they were pebbles during a mega tsunami that hit Africa thousands of years ago. This wasn't just a bad day at the beach. This mega tsunami was so powerful, it made the 2004 Indonesian and 2011 Japanese tsunamis look like kiddie pool splashes. Now, to give you an idea of how terrifying regular tsunamis already are, the Japan tsunami produced waves 133 feet tall. The Indian Ocean tsunami was slightly smaller, but it took over 200,000 lives across many countries. Now imagine something way worse. You see, for a long time, scientists thought waves that big were just science fiction. But then they found these enormous boulders, massive chunks of rock, flung far inland, and did the math. It turns out only waves around 800 feet tall could have pulled off that kind of rocky vandalism. And the culprit? A volcano that literally fell apart into the ocean and triggered one of the most powerful tsunamis Earth has ever seen. Usually, tsunamis are blamed on underwater earthquakes, tectonic plates getting into slap fights. But volcanoes? Oh, they've got tsunami potential too. In 1883, for example, a volcano in Indonesia named Krakatoa erupted for 6 months non-stop until it exploded, and the explosion was heard all the way in Australia. This triggered many tsunamis, some almost 100 feet tall. Still, that was more like a toe dip compared to the full cannonball from the mega tsunami. Back in ancient times, the volcano that crumbled during the mega tsunami was huge, and it didn't just fall apart. It lost a chunk that was 10 times the size of Mount Everest. 10 Mount Everests. It was like the Earth wanted to see what would happen if we threw a mountain into the ocean just for fun. It was so massive that when the entire side of the volcano belly flopped into the Atlantic, it created waves that could cover the Statue of Liberty 3 times. It also destroyed an island more than 30 miles away. The volcano behind this real-life Michael Bay scene was called Fogo, located on, you guessed it, Fogo Island. This island is basically just a whole single volcano that rose from the sea thanks to a magma hotspot, a place in the ocean where a lot of magma escapes and erupts like an underwater volcano. Over time, this magma cooled and stacked up like pancakes until, voila, after 7 major eruptions, the island popped out of the ocean like it was playing peekaboo. Surprise, it's a volcano. But Fogo's dramatic entrance was also a ticking time bomb. You see, the more a volcano grows, the heavier it gets, and if there's not enough magma inside it to support it, the whole thing can just collapse. Sometimes it doesn't take much. A minor earthquake, some erosion, or just a poor foundation made of soft sediment can trigger a collapse. It's like a really tall guy trying to balance over a bunch of marbles. Fogo had all the bad luck ingredients. Too tall, too heavy, and built on squishy ground. And it gets worse. As the volcano grows heavier, it starts squishing the magma underneath. That lava can't rise, so it just simmers down there, slowly thickening like soup left on a burner for too long. Gases build up, pressure increases, and eventually, kaboom! It's the volcanic version of eating too many burritos and then trying to hold in a sneeze. This massive pressure and imbalance can trigger what's called a flank collapse, which is science speak for oops, half the volcano just fell into the ocean. That's what happened with Fogo. Most of the volcanic islands that form this way are long gone, but Fogo is still very much alive and kicking. In fact, it last erupted in 2014, and considering that it goes off every 20 years, maybe don't travel to Fogo Island in around 2034. For the longest time, scientists believe only big, bulky volcanic islands could collapse like this. But new research says that even smaller, skinnier guys, like the Danny DeVitos of the island world, aren't safe either. The thing is that small volcanic islands only seem stable because of their small mass. It's like Danny DeVito and Arnold Schwarzenegger both slipping on the ice. Arnie's fall might cause more chaos, but Danny can still go flying. And those little collapses? Yes, they matter. Take Santa Maria, a tiny island that's about 170 times smaller than Hawaii. It has collapsed multiple times, not because it wanted to, but because it's basically standing on soggy breadcrumbs. Its foundation is loose marine sediment, and to make things worse, it's sitting right next to the East Azores Fault, where 3 tectonic plates meet up for daily slap fights. This fault is responsible for many earthquakes and even some tsunamis that happened in Lisbon in the past, so you can imagine what it's like living right above it. Every time the volcano in Santa Maria erupts and grows, it also sinks. But when a chunk collapses, it bounces back up like a buoy. This seamount to island again roller coaster means that Santa Maria has popped in and out of the ocean like a submarine playing peekaboo, and with every peak comes a potential tsunami. Another volcano with similar trust issues is Pacaya, located in Guatemala. Between 2011 and 2013, scientists spotted strange movements in the soil, tiny shifts that suggested something underneath was getting restless. Sure enough, in 2014, Pacaya erupted. Luckily, it didn't collapse, but that risk still looms, especially if magma gets trapped in it like it did with Fogo. The consequences could be explosive, literally. In fact, about 1,000 years ago, Pacaya experienced a collapse that sent debris avalanches more than 15 miles away. Since then, it's rebuilt itself like a fiery phoenix, but it could still crumble again. That's why volcanologists obsess over the tiniest wobbles. It's not paranoia if the mountain really might fall. Now you might be thinking here, okay, but that was the past. Surely that kind of ridiculous mega tsunami collapse can't happen again, right? Well, welcome to the 21st century. Islands like Hawaii, La Palma in Spain, and various parts of the Caribbean are sitting on the same kind of geological whoopee cushions. All it takes is the right combo: loose foundation, steep slopes, maybe some trapped magma, and boom, flank collapse. In fact, it's already happened recently. In 2018, Anak Krakatau, the volcanic baby of the infamous Krakatoa, lost a big chunk of itself during an eruption. It caused a tsunami, but it was more awkward than devastating, like a volcano losing its pants on stage. Embarrassing, but survivable. But that's just amateur hour compared to history's real showstoppers. Ritter Island's 1888 collapse was so intense that the island literally got shorter. It went from being more than 2,000 feet tall to a mere 460 feet. But the record holder is the legendary Latua Bay megasplash from 1958, where a 7.8 magnitude earthquake triggered a massive landslide that sent a wave taller than the Empire State Building roaring through Alaska at highway speeds. Strangely enough, only 5 people lost their lives here, but on the other hand, the destruction path it left behind can still be seen today, all the way from space. Melting glaciers and ice caps can make volcanoes collapse too. When they melt, there's a sudden decrease in pressure on Earth's crust that can destabilize entire volcanoes. It's called isostatic rebound. It's like suddenly yanking a chair out from under someone who's been sitting still for centuries. Whoops. Also, here's something you probably never thought you'd worry about on your island getaway. Some volcanic islands grow outward as lava pours into the sea, creating unstable platforms known as lava deltas. These deltas can collapse without warning, taking newly formed land, and sometimes tourists too, right back into the ocean. No pressure though, just thought, maybe you want to stay off steaming new land. So yeah, next time you're lounging on a beachy volcanic island thinking, wow, this place is paradise, just remember, it might also be a ticking geological time bomb with a flair for the dramatic. From ancient mountain-sized cannonballs to surprise lava deltas, volcanoes have a history of keeping things spicy. That's it for today. So hey, if you pacified your curiosity, then give